Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Hi, everyone.
Hello.
Hey there.
Welcome, everyone, to GraphQL Galaxy 2022. Thank you for being part of it and being here today. We hope that you enjoy the talks, and don't forget to ask questions afterwards on Discord. Our speakers will be extremely happy to answer any questions that you have. My name is Cecilia Martinez. I'm a developer advocate for AppFlow at Ionic. I'm based in Atlanta, Georgia, and you can find me online at Cecilia Creates. I was previously at Cypress and Replay and love working with open source developer tools. I am also like to volunteer in the tech community. I'm a lead volunteer with Women Who Code Front End, the chapter head for Out in Tech Atlanta, and I'm part of the GitHub Stars program. Alexander?
And hi, I'm Alexander. I'm based in the Netherlands. I'm one of the lead engineers at Open Social, where I've built our real-time chat. I'm a co-maintainer of the GraphQL module for Drupal, and you can find me online as @KingDutch. And today I'll be your host on the Milky Way track. Yuri.
Hi, everyone. I'm Uli. I'm very happy to be here. I'm happy to help Git Nation and with GraphQL Galaxy, and happy to MC here. I'm a founder of a group called The Guild. Maybe some of you have heard about us. We're doing a lot of open source solutions in the GraphQL space and outside the GraphQL space. We also build SaaS products and stuff like that. We do consulting, support, and we just love supporting the community in general. We're also a member of the GraphQL Foundation. And yeah, I'm really happy to be here and really excited about it. Cecilia.
Now, wow, take a look at this number. So we have more than 5,000 people registered this year for GraphQL Galaxy. Thank you so much for being a part of this event. Uri?
Yeah, it's really impressive. I mean, not only the number, but also how people are joining from all around the world. Like you can see on the map, the GraphQL community is really big, and it's really exciting to see so many people from so many places around the world. And also, I think what I really like about the GraphQL Galaxy and the Git Nation conferences is that like not only everyone can join, but can participate. So if you want to join the conversation and the activity, you can actually go in a couple of different channels. One of them is the Slido. So Slido is a place where you can come in and you can you can answer polls and see results of Q&A sessions during the talks. So if you want to join, you go to sli.do, you enter the code 0812, and then you can take part of the poll from each specific speaker. And at the end of each talk, we'll discuss the results during the Q&A. For now, let's see how it works. So you can see here, there's like a question. When did you attend the GraphQL Galaxy for the first time? 2022, which 2021 and 2020. And you can see the results. Yeah, and this the same thing, the same type of the same thing will happen through each of the talks, and you can participate in the talk, and the questions are coming from the speakers themselves. So we really want you to participate and answer. I also want to thank the program committee. The program committee is the group that actually came up with all the lineup today. We hope the lineup will be very good for you and you would enjoy it. During the lineup is like the people who are part of the program committee is Taz and Vish and Jamie. They put in a lot of effort to make that conference as entertaining as teaching as possible for all of you. Thank you for all of them. Cecilia.
Yes, thank you. And a huge shout out to our sponsors who support the GraphQL Galaxy Conference. Thank you to Solo.io, Neo4j, Stackhawk, Honeypot, and Focus Reactive. We could not be here without you and appreciate your support. I also want to thank our media partners, CodeStacker, which is a YouTube channel about web development and coding languages like HTML, CSS, Sass, JavaScript, and TypeScript, as well as Jamie Barton's YouTube channel. You can learn something new with GraphQL every single week with screencasts by Jamie Barton. Thank you for your support. Alexander, back to you.
And we also want to see Twitter full of today's events. So show us how and where you're watching and tweet at us with a photo. Tweet it with the hashtag GraphQL Galaxy, because we'll be looking out for your photo tweets, and we'll have a raffle of multi-passes for Git Nation conferences and t-shirts. So do not forget to post your photo of how you're watching on Twitter with the hashtag GraphQL Galaxy.
Yeah, and we already have some tweets coming out there, so follow the tweet and see what we have. Here you can see our amazing MCs on the backstage. Yeah.
And the winners
Cecilia.
of the raffle will get t-shirts just like this one from Git Nation, as well as we are giving away 3 winners a Git Nation multi-pass. So the multi-pass gives you remote access to a batch of JS conferences like RemixConf, React Day Berlin, JS Nation, Tech Leads JS, Node Congress, and many more. You can find out more on the Git Nation portal at portal.gitnation.org/multipass. Uri?
Yeah, and if you want to look at the whole agenda and see, what all the events are about and what is most interesting for you, just go to graphqlgalaxy.com and you can see all the information there. Alex.
So here you see a screenshot of what the navigation on the website looks like. The main screen has the video player that plays the live feed. And at the top, you can see the 2 tabs that have our tracks, Andromeda and Milky Way. Below the video player, you can see the true tracks of the talk. And here you can see what is live at the moment and what's coming next. Then there's a track with speaker rooms. Just click on them and you'll enter spatial chat, where in a separate room, you can talk to the speakers from the Milky Way track directly. How cool is that? And also you can join discussion rooms in spatial chat. We'll cover that in a moment. If you're lost at any point, just write us in the troubleshooting channel on Discord, and we are there to help you out and make sure that your conference experience is awesome.
Yeah, and if you want to join the special chat, which is really cool because you can hang out with remote audience, and you can come in any time, and you can actually watch the talks together with others that are remote, have a conversation with them, talk about stuff that are happening here. You can do that right away. We really encourage people to join the special chat. We want to get as much engagement and want to hear all of your feedback and thought, everything that's happening here. Also, you can please join the Discord. You can use the GraphQL Galaxy channel to submit questions for the speakers themselves. In order to join, there's a link on the watch page or in your GraphQL, in your org emails that you got from GraphQL Galaxy. And let's test it right now. You can go right now to the Andromeda Q&A channel or the Milky Way channel. Post all your questions, emojis, whatever you want to say, and say hi to everyone. Cecilia.
Yes, and what is a conference without an after party? So we have an after party program which everyone is welcome to participate in. We're going to play some games, like code names or draw battle, and we can also chat with each other. So we'll have lots of fun, and it's going to be in spatial.chat. As always, we want everyone to feel safe and have a good time during our event. We do have a code of conduct at getnation.org/COC. Please go read it, and if at any time you feel there's been a violation, email us at coc@getnation.org, and we will take care of it right away. We do not tolerate any form of harassment in any of our channels, and that includes Discord and the spatial chat. Alexander?
And also, don't forget to take part in the discussions around GraphQL tomorrow on December 9th. Here's the discussion room schedule. Tomorrow, we're having a discussion room about federation at 4 p.m. Central European time with Lucas Leadbetter. There will be a discussion in the security room with Thomas Heijenbrock at 4:35 Central European time. There will be a discussion around specification updates with Benji and Lucas Leadbetter at 5:10. And finally, we'll round off with a discussion room about GraphQL clients at 5:45 Central European time. So feel free to join these debates tomorrow via spatial chat or from the timeline under the player.
Yeah, and also you can please check out the graphqlgalaxy.com/jobs. You can find there new opportunities for yourself. There's a lot of job offers from our sponsors. Same goes for graphqlgalaxy.com/perks. Also there, our sponsors are giving you all kinds of cool stuff. So go there, and special offers. So go there and try it out. And also, most importantly, the Git Nation team really likes, and I can say from my own experience, they like to hear from the feedback and like to continuously improve from year to year. So if you go to graphqlgalaxy.com/feedback, please go there and let us know everything that the team can improve. I submitted many feedbacks throughout the years. They were really quick to respond and to improve, and we really like to hear from you. Back to you, Cecilia.
All right, so now it's time to check out the poll results. So this is the results from the question that you answered that we asked earlier in the presentation. So when did you attend GraphQL Galaxy for the first time? So it looks like we have a lot of first-time attendees this year, which is super, super exciting. And thank you to those who are back from a previous year. We love to see it, and we love to have you here. All right, well, let's go ahead and kick things off and get started. Let's start with a huge round of virtual applause for our first speaker on the Andromeda track. We have Ryan Chunky, founder at CourseLift. He will be giving a talk on rock solid ready and GraphQL apps for people in a hurry. Ryan is a full stack developer, and he loves all things React, Node, and GraphQL. He's a big fan of web security, and it's a topic that he's written about extensively and taught thousands of developers on. He's also the founder of CourseLift, which is a course hosting platform that helps authors earn more from their online courses. He also blogs at ryanchunky.com. So Ryan does have a question for us. So if you can go to get back on Slido 0812. Ryan has a question here. What's the command to generate a full schema for a model in Redwood.js? The options are generate schema model, generate SDL model, generate GraphQL mode, or make SDL model. So answer with what you think the correct answer is, and Ryan will discuss that in the Q&A. Take a look at the responses there. Also, don't forget to ask questions on Discord in the Andromeda Q&A channel. That way we can answer those questions for you after Ryan's talk. So again, let's give another big welcome for Ryan, and the stage is yours.
Well, it's definitely been a minute since I started working with GraphQL. It's been about 5 years, in fact, and in technology years, that's quite a while. And when I was first starting out with GraphQL, I didn't really care how long it would take to work on a project or get a GraphQL app up and running. But these days, I find more and more that I'm in a hurry with my projects, and I want something that is faster to get going with and faster to maintain. And so that's what I'm going to talk to you about today, how to deal with React specifically and GraphQL if you are in a hurry. My name is Ryan, and I do a lot of things around the web, but one thing I'm very focused on today is CourseLift. And CourseLift is course hosting for people who want to have all of the mechanics of how to put together their course landing pages, how to put together their sales information, etc., done for them so that they can focus on making their course, and we help them sell their course. Check it out at CourseLift on Twitter if you're interested. So going back to 2017, 5 years ago, when I started getting involved with GraphQL. It was an awesome time because there was just so much energy in the community around GraphQL. It was fairly new. I know that it dates back to 2012 at its inception, but it was around this time in 2017 that people started getting really excited about it. And that excitement was really palpable. This is me at GraphQL Summit in San Francisco. I got to do a talk there back in 2017, and there was just a ton of energy in the room about GraphQL. People wanted to put it everywhere. People wanted to use it in all their APIs from all their front ends, and you could really get that sense at the conference. And it was around this time that I started working on a large project for a brand new client. I had been working for Auth0 at the time, but I started to break out and go on my own doing consulting work, and I started to work on big projects that used GraphQL in this new case of this new project. And it was around this time that I was really getting my footing with GraphQL. I was trying to figure out how to work it into this project and how to make it really good for the client in particular. And what I noticed is that there were a lot of frustrations that came about as I started working on this project. And I could bucket these into a few different categories. And the first one is that it was kind of unclear to me at the time how to deal with different modules, how to separate parts of the API into different portions, how to deal with things like, okay, I want a users module, and then I want to have a module for some other resource. How to bucket those things off and then bring them all together in a cohesive way just wasn't really clearly established. And so because there weren't these conventions in place, you were sort of left to figure those things out on your own. And so I came up with a convention that worked in my project, but it definitely was quite bespoke and maybe wasn't the best way to do things. This led, I think, to a lot of repetitive and manual work. I'd be copying and pasting module folders over, changing names, and then having to import things into a main file, put all of that stuff up into a make executable schema in Node. And it was just this repetitive kind of manual task that I had to deal with. And at that time, also, there were no really good front-end abstractions for your front-end, back-end author time integration. I remember that it wasn't really all that clear how to get information when you're working on the front end as to what the back end could offer up in terms of resources or fields on your resources. And so this integration between your front-end query clients and your back-end schema, it just wasn't all that well established at that time, how to make those things work well together. So what this led to really was a set of bespoke and brittle solutions. I put together things that I thought worked well in the application, and it turned out that these were a little bit brittle. So, things like things breaking as I would add new modules, forgetting to import one of the new pieces of the schema into my main file where I make the executable schema. Things like having to deal with file uploads and authentication, all these different pieces of the application that are fairly standard in most places, just weren't all that standard in GraphQL at that time. Things have definitely gotten better over the years. Adoption has grown, more and more large companies are using GraphQL, and more developers everywhere are trying it out. I think nearly all the technical points of GraphQL have gotten better over the years. We've got better server libraries these days. We've got more of them, in fact. We've got better ways to arrange these conventions across our projects. Tooling is better all around. We've got integrations from code editors, and we've got integrations between front ends and back ends at author time now, which is great. We've got things like code generation, which helps to make modifications to our code in an easy way. And ultimately, type safety has really been been a big benefit of all of this. Being able to know the types that are available on the GraphQL API, and then being able to use those across the application stack has been really beneficial for author time type safety. But I think there's still some room for improvements, and I think that's because new GraphQL developers, they're often left confused. I've talked to many GraphQL developers who just have a hard time understanding all the pieces at play when they're trying to get started. And I think that's because the learning loop for GraphQL can be quite challenging. Needing to figure out like what a schema is, what a resolver is, and how to interact with those two things from the client can be a bit challenging. This question of like, where does GraphQL fit in the stack can be one that is challenging as well. Some people think that you should put GraphQL between your server and your database, for example, whereas others think it's strictly from your client to your server. And so informing new developers on where GraphQL really should fit into your stack can be a challenge. How do you work with other APIs when you're dealing with GraphQL? How do you work with APIs that aren't built on GraphQL, trying to integrate those? And then what tools are needed to make the whole stack fit together? That can be a challenge for new developers as well. And so I think if we can give early wins in the sense of being able to figure out the clear benefits of GraphQL in a very quick way, I think that it's possible then to get developers more excited about GraphQL. And so if we want more GraphQL adoption, if we want more people to be trying it out and using it in their projects, I think that focusing on those early quick wins is a critical piece of it. So in my mind, there's an ideal experience, and it kind of looks like this. We should have the benefits, the clear benefits of that client-server relationship be more easily seen at the outset without having to think about all the mechanics. So without having to think about, well, what's the definition exactly of a schema? What does a resolver mean? What is the client piece? Like, what is that all about? Instead, being able to show the clear contract that exists between those things and being able to do so in a way where the developer doesn't need to think about all the internals and the mechanics. I think that is a very big win. Having a way to be able to handle other pieces that you would find in any other kind of environment, I think is important too. Things like authentication and authorization, file uploads, those sorts of things, being able to have a clear way to show how to do those things because they're necessities in most applications. I think that being able to demonstrate how to do those things early and easily is an important part. And then automatically be informed about the GraphQL schema across the stack. So getting type information from the GraphQL schema that exists, being able to use that type information to inform ourselves at author time, and having an easy way to do that, I think, is key. There are numerous ways that this is made easier these days. There are more and more frameworks, more and more kind of getting started packages out there that help with this sort of thing. But the one that I'll talk about today, and the one that I think is probably the best way to bring this experience to life, is a newer framework called Redwood.js. Redwood.js, it's this highly opinionated framework. It brings together lots of different pieces of tech into a very cohesive and very nice to use way. And one of the things that I love about it is it offers a lot of conventions and patterns that make it really easy to have consistency across an application, especially if you're working with multiple developers. And it's a very nice framework that brings together a lot of great tech that we'll touch on today. What does a Redwood app look like? Well, it brings together these items. We've got React, GraphQL, Node, Prisma, Storybook, and Jest. Those are the main pieces. There are some others as well. And it brings these technologies together in a way that is super cohesive and super easy to get started with and to go beyond with. We don't have to worry too much about these pieces, as our application grows. They just keep working and they work very well. When it comes to a Redwood app, we've got two sides. Redwood apps exist in a mono repo in a Yarn workspace. We've got a web side and we've got an API side. And so this mono repo approach is great because it allows us to work within a single project, but work on both those sides, the web and the API side. And so the question often is around Redwood, what does it do? Does it just kind of like install a bunch of packages for us for those technologies? Does it just give us a package JSON and then we, install all those individual pieces of tech? And the answer is no, it has a lot more that it does. It gives us a huge set of generators, which saves a ton of time generating code. We get scaffolding for things like being able to take a model and then be able to give ourselves the whole CRUD story around it. So all of the pieces of schema that we need, resolvers that we need, and then also all of the front-end parts that we need as well to be able to do CRUD. We get authentication out of the box. So, typically if you're working with authentication in GraphQL, you might be reaching for a custom directive. We get that stuff automatically with Redwood. We get routing solved for us with Redwood. We get a very nice implementation of a router within the React layer with Redwood. It's a very smart abstraction, works very well. We get things like layouts, convention for having an application shell, for example, that can be used across the application. We get code mods. When it comes time to upgrade the Redwood version that you're on, oftentimes there's code that needs to be updated across the application, and we can just run a simple npx command to get that code updated across the whole app for us, which is great. We get to work within monorepos. It makes things much simpler when we're dealing with a single repo for the front end and back end of our application stack, rather than having multiple pieces that we have to worry about, committed to different repos and deployed in different ways, etc. And then the thing I love most is just custom patterns that Redwood offers. Things like cells, which we'll get into. Cells are this abstraction that gives us a way to handle the whole life cycle of a CRUD operation. And we're going to see that in some more detail. Generating components is very simple. We use a yarn command. So it's yarn redwood generate components, and then whatever your component name is, for example. We get the same thing with a page. So whereas we would have a component that might just be an isolated bit of a UI that we might be working on, we might also want to have a page, which is kind of like a larger shell where our components go. And then we might want to generate a layout as well, which is going to be a kind of an application shell. You can think of it like that, which ultimately offers up something that looks like this, having our app shell with any number of pages that might be in it. And then those pages themselves would implement various components. And this is a pretty typical way that an application is laid out. You've got like maybe a navbar and sidebar in your layout. And then you've got pages inside that can be navigated to, and then components that do the work of the application. Then, if we're dealing with a server resource, something that would reside as a schema bit on our server with a resolver, we can target an SDL to be generated. So it'd be yarn redwood generate an SDL, giving it a name, and then we would get a full GraphQL schema, a full set of resolvers, and we would be able to use it immediately with GraphQL calls. So that's a lot of the theory. Why don't we see Redwood.js in action, and we can see how GraphQL really shines within a Redwood app. So when we're dealing with Redwood and we want to get started with a new project, we can do so with yarn. We can do yarn create redwood app and then give the app a name. Let's call this one GraphQL Galaxy. And then I'm going to say I want TypeScript. Typically, this is what I always do. TypeScript is what I use by default, but you can get Redwood in a standard JS flavor if you want as well. Just don't put on the -- TypeScript at the end. When we do that, we're going to get a new application started for us. It's going to install all sorts of dependencies. It's going to go through and put together all of the packages that are within a Redwood application. So React, GraphQL, we've got Storybook, Jest, and more. And it's going to put all those things together for us into our new package. It's going to run yarn install, and it's going to generate types right off of the bat. So type generation is something that happens automatically within Redwood.js, and that's going to happen for us right here at the installation phase as well. So we'll give this just a minute to run, and then we'll hop into the project and see how to work with GraphQL in it. All right, we are all set here, so I'm going to cd into GraphQL Galaxy, and let's open this up in VS Code. And we'll give a really quick tour here of what's in the directories. So as I mentioned, we've got two sides. We've got a web side and an API side. Here's our web side, all of the stuff that goes into the client portion of our application. And then here's the API side. And this is where stuff like our database models reside with Prisma. And it's also where we're going to manage our GraphQL pieces. So the first thing we might do is we might fire this up and take a look at what it looks like in the browser. For that, we can do yarn redwood, or if we want to, keep it short, rw dev. And when we do, we are going to have a new project over in the browser that we can look at. So this is the main splash page for Redwood. We don't have anything yet in terms of pages, but we can generate one. And let's do that right now. Let's go and generate a page. To do that, I'm going to open up a new terminal, and I'm going to do yarn redwood, or just RW for short, generate a page, and let's call this page our Galaxy page. And we'll see what this looks like over in the browser. When we generate the page, it goes into the web directory. If we go to source, into pages, there's our Galaxy page, and it's got things that we are interested in, like our React component that makes up the page, and also a test that comes along with it for free, and a storybook story as well that we can work on. Over here, our page is showing up. Let's navigate to it. Here is our Galaxy page. So for this page, maybe we want to have a Galaxy resource on our backend that we can work with. So something in our database, a resource that we can, do some CRUD operations against. For that, let's come over here, back over to the terminal, and we are now going to use something called a scaffold. But the first thing we have to do actually is set up our model. Let's come to the API directory, and we will go into our model, which is going to be under db schema.prisma. And what we'll do is we'll take out this example that comes with the Redwood installation, and we'll give ourselves a new model called Galaxy. So this is going to be like a table which will hold galaxies. So maybe the Milky Way and Andromeda and all the other ones that exist in the vast universe. Let's start by having an ID field here. We'll just make this an integer for now, and the default value can just be auto increments. So we'll auto increment that ID. We'll want to say that this is also the ID for this particular table. Might want a name. Name could be string. Might want a description, which will be string as well. And then typically we want to keep track of when a resource was created. So created at can be a field that is a date time type, and the default can be now. And then maybe updated at can be there as well, and we can track when updates happen. That's a date time field, and we can use the updated at decorator so that we can automatically get those values. So we have a Galaxy table, and we are using, in this case, SQLite as our database. If we run installation on this, we should get everything wired up. So let's, I should say, if we run our generator for this, we should get everything wired up. So we can do yarn redwood prisma db push. That should give us our database. So there's our database, dev.db, and it's going to have that Galaxy table in place now. And so what we can do to give ourselves a really easy way to work with data here is we can do yarn redwood scaffold, generate scaffold Galaxy. Let's run that command and we'll see what we get. So we have got a layout, we've got routes, we've got all sorts of stuff. If we go to our routes file here, this is our routing file at the React level. We've got a whole bunch of new paths. We have got a path where we can add a new galaxy. We've got a path where we can edit an existing one, and all sorts of stuff that points to different components that have been created for us if we take a look within our web directory. So we've got a new page here, which is a Galaxy page. I created an initial page called Galaxy, which we could probably get rid of now since we have another dedicated resource called Galaxy page. And then we've got a bunch of components that fit underneath this Galaxy resource, which will give us all of the stuff we want to do for managing CRUD. If we look in the API directory, we've got a bunch of stuff as well. For example, galaxies.sdl. So this is the GraphQL schema on the server that we want for managing this resource. And we can see that immediately it gives us what we might expect based on an initial kind of sampling of this model that's in the database. taking the fields that are on this model, we can interpolate here that we might want to have ID, name, description, all of these things available as parameters on this object. We get queries for galaxies, plural, a single galaxy by its ID. We get an ability to do mutations right away. And if you notice here, we are requiring auth right away. So we've got this, this decorator require auth. If we don't want that, we can choose to skip auth, which is useful at develop time. But it's a very nice feature of Redwood that it automatically will give us authentication to protect our resources in case we forget, for example. So we've got everything in place here to give ourselves a full CRUD operation, set of CRUD operations. If we look in the services directory here in galaxies.ts, these are the accompanying resolvers that will be used to do all this CRUD. So why don't we take a look over in the browser again? If we refresh, there's nothing on the page here, and that's because we need to get ourselves to a spot where we can edit it. So if we go to galaxies/new, here we go. We are able to add a new galaxy in Milky Way. Home. Let's call this home as a description. We'll save this. There's the record in our database. We can edit it to be something else. We can save that. We can delete it. We can show it. We've got all sorts of operations that are just given to us for free by Redwood by virtue of generating this scaffold. And the important part that I'll hone in on here is that all of the GraphQL parts are solved for us just by virtue of running that command. So for example, if we go to our components directory to Galaxy, and then we go to Galaxy Cell, here is our GraphQL query that was generated. It asks for all of the fields back that we've got on that model. It sets up all of the states that we might be in for doing a CRUD operation. So what if there is a successful operation that happens? It sets us up for that. What if we're in a loading state? What if we're empty or there's a failure? It gives us those as well. And then the accompanying server pieces for this, like we already looked at, are already there, just generated automatically. So when we're thinking about a way for developers to get started with GraphQL in a very low friction way, a very easy way where they can just start to see the benefits of GraphQL itself, I think that Redwood provides a very clear path for that. Things are generated automatically. We don't need to spend time figuring out exactly the syntax of the SDL piece that we might need, how to tie up a resolver to it, how to put the query piece in. It's just done for us automatically. And then we can spend time figuring out how all of these pieces operate together. But that very easy way to get started is done for us, which I think is a very big win. So if you're new to GraphQL yourself and you like what you've seen in terms of a clear getting started path for it, check out redwoodjs.com, and it's as easy as we showed today. Or if you're an experienced GraphQL developer and someone you know is interested in GraphQL, I might recommend that you tell them about Redwood so that they can have that very easy getting started experience, get the mechanics out of the way, get a very clear path to just getting the benefit first, and then figure out the rest after. Thanks very much. My name is Ryan, and once again, I am the founder of CourseLift. If you're interested in course hosting that helps you market and sell your courses, check out CourseLift.com or CourseLift on Twitter. Thanks very much.
All right. Thank you so much, Ryan, for that amazing talk. Why don't you go ahead and join me on stage?
Hi, how are you?
Hey, Ryan, welcome. Thank you so much for being here. And
Absolutely.
just a reminder to the attendees, you can ask your questions to Ryan on Discord in the Andromeda Q&A channel. So yeah, Ryan, let's go ahead and start by taking a look at the results from the poll question that you asked before your talk. So again, on Slido, we can take a look and see. It looks like most people have answered, about 50% have answered generate schema model. Closely behind is generate SDL model. So what do you think about those answers?
I think people are on kind of the right track, but it looks like the correct one was voted lower than the incorrect one. It is SDL to get yourself a a full set of CRUD resolvers of your SDL for your backend. So if you have some model in your Prisma schema, you can do yarn redwood generate SDL and then your model name, and then you get all that code generated for you.
Awesome. Yeah, it sounds like a really great way to just get things rolling and give you everything that you need. So great. Awesome. Well, let's go ahead and
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
about that. And so thank you so much, Ryan, for answering our questions and for your amazing talk. We really appreciate you being here.
Absolutely. Happy to be here. Thank you.
Awesome. All right, Uri, take it away.
Hi, everyone. So first of all, we want to thank our sponsors. So Solo.io, we want to give them a big round of applause. They're our platinum sponsor. Solo.io offers simplified GraphQL deployments by integrating GraphQL server and API security into a unified cloud-native platform. So make sure to check them out. And next, I'm going to introduce our next speaker on the Andromeda track. I happen to know this person very well. It's Lauren Quast, and his talk, by the way, as you can see on the title, is Future-Proof GraphQL Schema Design. But ever since it was submitted, big things have happened, and Yoga v3 has actually been released. So the new title is actually How to Build Great GraphQL Servers, GraphQL Yoga v3. Lauren is a developer that started exploring GraphQL by leading the private and later public API development of a startup he was working in. And while working on that, he realized there's a lot of unresolved problems and challenges in the GraphQL space. So he started contributing to famous libraries, such as GraphQL Code Generator and GraphQL Tools, which the guild maintains. And the more he dove deep, the more he wanted to transition more and more and became a full-time, basically, at the end at the guild. And I'm personally very proud to work with him. I think he's a very, very smart guy, and I'm really looking forward for his talk. Now, during this talk, Lauren asked a question for all of you, and he was wondering what upcoming GraphQL features are you most hyped about? Like, what do you really want to see the most? The things that he wrote down as possibilities are client controlled nullability, defer and stream, incremental delivery, the one-off directive, and fragments, arguments, and modularized fragments. So you can go to Slido and answer. It's interesting. I'm personally also really interested to hear your opinions about these features. So don't forget to ask the questions during the talk on Discord on the Andromeda Q&A. Lauren will be there. And let's give a big round of applause for Lauren. And Lauren, the stage is yours.
Hello everyone. Today we're going to talk about building great GraphQL server experiences with GraphQL Yoga version 3. First of all, I'm Lauren and I'm an open source developer at the Guild. You can find me on Twitter and GitHub, where I'm mostly posting about open source development. Before we start with the actual talk, let's have a few words about the Guild. So we at the Guild, we are a group of developers that have been doing open source since almost forever. And we assembled together for client work. And what we're doing is basically we're working with clients, solving their problems. And from there on, we look at those issues, see how we can abstract them and share them with the world. And usually that will result in open source software that we then publish and make available for everyone. So basically we solve problems and feed them back into open source. So here's a short summary of some of our most prominent projects that we're currently having. GraphQL Code Generator, which is a tool for generating code and type definitions for any language for your existing GraphQL server. Then we have GraphQL Mesh, which is basically a library for converting any data source into a GraphQL SDK or gateway. We have GraphQL Inspector, which is a schema validation and breaking change detection tool for your CI or CD flow. We also have GraphQL Hive, which is basically a GraphQL schema registry and insight platforms for teams. It's available as a self-hosted version, but also as a SaaS version. Then we also have GraphQL tools, which is an utility for all kinds of GraphQL schema and server tooling that you might need. And then also very popular is GraphQL Scalars, which is Scala and data types validation types for GraphQL JS. Yeah, that is basically only a small excerpt of all the stuff we have. You can find more of that on the guild.dev, but today we're gonna talk about GraphQL Yoga version 3. So before we start with that, let's quickly give you a short overview of what happened in the past, how Yoga evolved, and how we got to till today. So I'll try to keep it short. So someday in the past, Yoga was created by Prisma, and the reason for that was that at this point, all the available GraphQL server solutions that were already there were far too complicated. So for new people that started coming into the GraphQL space, they had a hard start for actually getting started with GraphQL. So Prisma took the existing Apollo server, wrapped it in another layer, and out of that Yoga was born. Then shortly after that, the community saw this GraphQL Yoga server, and for obvious reasons, ease of use and batteries included, they started adopting it. Then a while later, Prisma moved away from GraphQL. They introduced their own SDL, ditched GraphQL, and inevitably then GraphQL Yoga ended up being unmaintained for a long time actually, and a lot of GitHub issues and other discussions piled up. That's when the guild came in. So last year we reached out to Prisma team and asked them what's their plan for Yoga and whether we should help them out. And in the end, we adopted Yoga. We got the repository transferred over to us, and then we started working on it. The first milestone that we had in mind was Yoga version 2. And basically the mission behind Yoga version 2 was to bring the Yoga library back into a state where it's maintained, where all the existing issues and feedback got addressed, critical dependencies were updated. And yeah, that happened about half a year ago, back in June. We finally released Yoga version 2. And then, just a month ago, we released GraphQL Yoga version 3. But what happened from GraphQL Yoga version 2 to GraphQL Yoga version 3? That's what I'm going to talk about now. So actually in June, when we just released GraphQL Yoga version 2, all of the guild members were assembling back in San Francisco, and we were sitting together and we were brainstorming about the GraphQL server vision that everyone had. Like, everyone had some kind of vision, but every individual in the guild had different needs, and coming from different backgrounds and working on different customer projects, there were different needs. So after a lot of intense discussions, we came to the following key points that are valuable. So first of all, it should be easy to get started. Like GraphQL Yoga version 1 was easy to get started, and GraphQL Yoga version 2 was also easy to get started. We wanted to keep that for GraphQL Yoga version 3. Then the other thing that we wanted to do is to make GraphQL Yoga version 3 as production ready by default as possible, so batteries included. The details about this I'm gonna talk to you about later. So then also we wanted GraphQL Yoga to fit into any existing stack, and that does not mean, oh, I want to use it with Express or with Fastify, or I want to use SDL first or code first. When we said fit into any existing stack, we actually meant any existing JavaScript runtime out there, whether it's Dino, Bun, Cloudflare workers. We wanted to support them all. Then also we wanted to hide unnecessary complexity, which is kind of related to easy to get started. Also, we wanted to provide solution paths for common problems, like persistent operations, Apollo Federation, all those fancy words that are out there. We wanted to address them and give solutions for them. And then in the end, we also wanted to allow people or individuals to solve their own specific needs with yoga without having to ditch yoga or move out of yoga or having to fork yoga, which basically means we wanted to have a plug-in system that is as powerful as possible. So how did we achieve all those points? Let's start with easy to get started. So spinning up a GraphQL server with yoga is as easy as pie. With this code on the right, you get a full GraphQL server that supports all the latest GraphQL features, uses existing platform primitives. In this example, we're using a Node with the HTTP module. So you can also see that Yoga is not abstracting the Node HTTP handling away. It's just a request listener that you get from the Yoga library, and you can plug it into any HTTP server that's either specific for Node or Cloudflare Workers or Bun or Dino. And then also from that you get everything, including a GraphQL IDE. So another improvement that we did from Yoga version 2 is we finally upgraded to GraphQL 2, which is just awesome. We are mind blown by it. You get a new fresh look, you have better usability, like 10 times better usability. Also, GraphQL runs locally compared to like other open source GraphQL servers where they started not shipping an IDE with the GraphQL server and instead lure you into kind of using their self-hosted or cloud version of a playground. And also the best thing about GraphQL version 2 is that it was entirely built by the community. It's open source, and we intend to maintain to it and make it even more awesome. Then another thing that should be easy to use is GraphQL subscriptions. In the past, WebSockets were necessary for doing this because there were no alternatives actually. There's a huge history and incident between GraphQL subscriptions being not maintained and then people getting mad about it, and we thought let's try a fresh approach and let's try to use server-sent events, which is basically simple HTTP and does not require any custom WebSocket protocol overhead. So our goal was that you can write your GraphQL subscription and then do a simple curl request from within your terminal for getting a full subscription working. And we made it work. So on the right you can see a simple subscription setup, and on the upper left, lower left, you can just see a curl request using the accept text event stream header, which indicates that we are dealing with a server-sent event stream. And that's it. You will get the events as they occur, and the same as it works on curl, you can consume that in your browser. Another feature that is in the spec discussion since forever, and we thought should finally be available in a JavaScript server by default, is deference stream. It's such a powerful feature. It basically allows you to split your single query operation into parts where you know that certain parts are available faster and certain data is only available later because it's slow, it needs to do a deep database lookup or whatever. Just splitting those fields on demand and then streaming them to the clients improves the latency by a lot, and by that you can build much more responsive applications. So far, the only way for using this in GraphQL JS land was to actually install an experimental GraphQL version, get it to run with your existing server. But we solved it in a different way. So now you can actually use it without having to juggle around with this. You can just use GraphQL as it already is, GraphQL.js as it already is, and use Yoga for getting started without any additional configuration. So another thing that should be easy to get started is testing. In a lot of JavaScript frameworks, testing is always an afterthought. There's no documented way of doing that stuff. We wanted to make sure with Yoga that you get the full experience and answers for anything. Like, we thought that the best way for testing is actually to use the Fetch API, because that's how most developers are used to calling APIs in the first place. So we thought, okay, on the Yoga instance, we would just expose a fetch function that will exactly behave like if I would call the Yoga server for my browser. That way you can actually make sure that the tests are as close to real-world usage as possible. So the next thing we wanted to solve is to make Yoga production ready by default. As I said before, just from this code, you get a full functioning GraphQL server. But also, in addition to that, you get all kinds of production ready defaults in the background, which includes error masking, validation and parser caching, health checks, and even cores. So let's dive into them a bit. First of all, error masking. Like, everyone knows it. Masking errors or leaking errors to your users is a security threat. In this example, we're calling a load user function on our db object. That's a remote call, right? It tries to read from a database or something like that. Let's imagine that you fucked up configuring the credentials. Then the connection might fail. And instead of resolving a user, actually an exception will be raised. If this exception gets to the user, there would be a security issue. For example, in this code, I took it a bit to the top, where the error message would actually contain, first of all, the IP and the credentials for accessing the database. That would be fatal. And what we do instead by Yoga, for any unexpected error or exception that occurs, we will mask that by default. Then another bottleneck in many GraphQL servers is validation and parsing. In order to understand this, we first need to make sure that you understand what happens when you send a GraphQL request to the server. So first of all, we have a client, and it makes a HTTP request to the server. Then the server is actually first of all responsible for passing the request body and all the parameters, finding the correct route handler, and then once the server identified that we're dealing with a GraphQL request, then actually the GraphQL execution engine kicks in, and it is basically made out of three parts. We have parsing, validation, and execution. And usually the bottlenecks are parsing and validating. Why? Let's show you. So here we have an example of what parsing does. So what the client sends to the server is a query operation document. Before we can process that query operation document, we need to kind of convert it into an AST, an abstract syntax tree, which is basically an intermediate format that the execution layer will later on use for resolving the data sources and the fields that are selected within the GraphQL operation. And the problem with parsing is that it's slow because it's CPU bound. So the parser will basically go through the send GraphQL operation, and for each of those tokens, it will calculate stuff. And in the end, you get the AST out of it. If we execute the same operation over and over again, we don't need to parse it over and over again, right? What we can just do is slap an LRU cache on top of the parser function, and then when the same string is executed twice, the cached AST can just be provided. Same is for the validation layer. So in the validation layer, with the AST that just got parsed from the parser layer will be validated with a set of rules. For example, whether a specific field already is existent in our GraphQL schema. In this example, we have a me query with an ID and a name that will pass because all those fields are available in the GraphQL schema. And in the second example, we also have a password field that is requested by the client, but it does not exist in the server. So instead, we get an error that contains or cannot query field password on type user. So validation is actually also expensive because it again needs iteration through the whole query operation and all its fields. And because the results also are the same for the same query operation, we can also just slap an LRU cache between that, and the performance issue is solved. GraphQL Yoga also comes with health checks by default. For example, our customers and us use Docker and Kubernetes heavily, and there you need readiness checks, liveliness checks, and stuff like that. It's built into Yoga by default because we think that every GraphQL server or HTTP server should have built-in defaults for these by now. That's the industry standard. Then also Yoga deals with CORS. I don't want to go into details there because who really understand CORS? It just works, okay? Then the next step, or the next big thing we want to address is that Yoga fits into any existing stack. And as I said before, we're not talking about Node.js and all the frameworks that are built around it. Also talk about those new JavaScript runtimes, Cloudflare Workers, Dino, and Bun. For each of those, we wanted to provide an easy way of using it and also extending it. So if we're looking at our Express example, it's only slightly different from the one for using Node HTTP, the Node HTTP module. Instead of just passing it to the create server function, we create our Express app, and then we just use Yoga as the middleware for Express. Easy as pie. If we're looking at Bun, we can just also create our Yoga request handler, pass it to Bun, and that's it. Same for Dino. We create our request handler, pass it to the Dino specific serve function, that's it. And also for Cloudflare Workers, we create our Yoga request listener, attach it to the fetch event, that's it. So how does that even work? Because all those platforms are actually quite different from each other. Well, the solution here is the request and response model that made popular by the Fetch API. And basically the idea is that a request listener gets a request object and returns a response object. This was first made very popular by Cloudflare Workers, who adopted it. And they took it initially from the Fetch API. So within the browser, we have request and response for a long time. But now we also have it in the JavaScript server runtimes. And all those new wave JavaScript runtimes, Dino, Bun, and Cloudflare Workers already adopted this way of doing GraphQL, not GraphQL, HTTP request handlers. The only JavaScript runtime that's a bit late on that regard is Node. So in order to still support this with Node.js, we just built a small, very light polyfill or adapter for Node.js that addresses this gap until Node.js catches up. And this small layer is actually part of the Yoga core. And I want to thank here Ada, who made this all possible and came up with the initial idea. So with this, by building the GraphQL engine and the HTTP server around this around those primitives, we got something that actually runs everywhere. So another part of like fitting into an existing stack that was really important to us is that schema building should be possible in any way. Yoga should not be opinionated about how you build your schema. In fact, we actually ship a utility for like doing an SDL first schema, but it's not mandatory. And if you don't want to use it, it won't be within your code. If you, for example, deploy Yoga to Cloudflare workers, you will bundle your code, and we made sure that Yoga supports tree shaking. If you don't use the utilities, they won't be part of the bundle. You can choose your own preference, whether you're using SDL first, using GraphQL tools or GraphQL modules if you're more in the enterprise sector, or whether you want to do code first with GraphQL JS, not recommended, Potos or GQTX. It's your choice, your schema. Yoga accepts any GraphQL schema. Then the next step for us that we wanted to make sure is that Yoga is fully extendable. With Yoga version 2, we already made sure that parsing, validation, execution, and subscribing is completely extendable thanks to the envelope engine. But for Yoga version 3, we wanted to get a step further. Instead of only allowing to extend the GraphQL specific things, we also wanted to allow taking full control of the HTTP flow. That means hooking into routing, hooking into request passing, hooking into response building, in addition to the existing hooks for passing, validation, and execution. And from that, we were able to build very powerful plugins that some of them I'm going to showcase now. One that we're very proud of is the response cache. Basically, it's a cache for GraphQL operations. So if you execute a query operation with the same variables over and over again, you can cache it either globally or unique by user session. And then when the GraphQL operation is executed in a second or third or whatever time, the results will be served from the cache instead of the execution layer having to re-execute the whole GraphQL operation. That can drastically reduce your server load, and if you can either store the GraphQL execution results in memory, or if you have multiple server replicas, then you can use either Redis or Upstash as an alternative cache or shared cache between multiple instances. Another thing is automatic persistent queries. That was first made popular by Apollo, and basically it's a protocol for registering reoccurring GraphQL operations on the server in order to reduce client-to-server traffic. So a client can send an operation, register it, and then if it needs to re-execute the GraphQL operation, it can only send a hash on the second try, and the server already knows the operation from that hash, and thus the traffic from client to server is very low. Because what we saw is that usually as your GraphQL operations gets really big, the biggest bottleneck in the whole client to servers and server to client scenario is actually the client uploading the GraphQL document to the server. And as before, it's just plug in your plugin and that's it. Another thing is persistent operations, which is a bit similar to automatic persistent queries, but also adds another security layer. Because where APQ allow to ad hoc register queries and to save bandwidth, persistent operations only allow executing specific operations ahead of time. So any other GraphQL operation except those that are in the persistent operation store that tries to get executed will be rejected. And this is a pattern that we usually use in GraphQL production deployments, because there we usually want to avoid any arbitrary queries from clients we don't know. Another thing that we found very interesting is, what if we take a GraphQL API or schema and convert it into a REST API? Today we have a lot of debates around, GraphQL versus REST, what is the better one? We think both have their use cases. So why not develop your GraphQL schema, develop your schema as a GraphQL schema, and then convert it to a REST API. And with this plugin, you also get the full Swagger experience, where you can try out your endpoints and also document them, similar to what GraphQL does for GraphQL. And another thing that we are really proud of and very happy for the collaboration is GraphQL Armor, which is a collection of security plugins that's maintained by our friends from Escape Tech. And they basically provide a lot of utilities or plugins for public GraphQL APIs. So if you're building a private GraphQL API and you want to go to production, probably persistent operations is your best bet, because this allows executing arbitrary operations. But if your core product is the GraphQL API and you have many clients and you can't determine which kind of GraphQL operations will be executed ahead of time, having a set of security plugins that prevent excessive usage of the GraphQL API is mandatory in our opinion. So some of the plugins that are really cool is the token limit, which basically limits the amount of fields and tokens that a GraphQL operation can contain. Then we have the operation cost limit, so you can give fields a weight within your GraphQL schema, and if there's a query being executed that exceeds that query cost limit, it is automatically rejected. Depth limiting, classic one, probably the most well-known one in the GraphQL space. Once your GraphQL query exceeds a certain depth, it's just rejected. And also disabling field suggestions if you want to avoid people to auto-guess your schema. Then also we support Apollo Federation. So GraphQL Yoga can be both a gateway and a subgraph. So you can enjoy all the benefits you get from the Apollo ecosystem and use them in the Yoga ecosystem. And if that's not enough, you can still write your own plugins, right? So Yoga has a full flexible API for hooking into anything HTTP and GraphQL related. And you can solve your very use case specific needs or problems with your own plugins. And if your plugin is like solving a generic use case and you think that other people benefit from it, you can share it with the community. On the Envelope website, we have basically a plugin hub with over 40 plugins that are either maintained by the guild or community members, all around error handling, metrics, tracing, authentication, authorization, caching, and security. If you build a cool plugin, then reach out to us and we might feature it on there, because it might help other people aside from you. So, and the last thing that we wanted to make sure is that GraphQL Yoga is actually battle tested in production. So our battleship for testing stuff is GraphQL Hive, which is our schema registry that serves billions of requests each month. And before we actually released GraphQL Yoga version 3, we were running it in Hive for a long time already. Also, our good friends from Redwood.js and Parsera are already experimenting with the GraphQL Yoga version 3, and we are collaborating with them when upgrading the stuff, building a migration path for their users. So that's all I have to say today. My last suggestion for you is to try out GraphQL Yoga version 3. Thank you.
Wow, what a great talk. Of course, I'm biased, but I'm very, very excited for Yoga V3. Thanks, Lauren, for this amazing talk. And let's welcome Lauren on stage. Welcome, Lauren.
Hey there.
Hi, good to have you.
Thank you for having me.
So first question, first let's look at the poll question. So you asked people what upcoming GraphQL features are they most hyped about? Let's look at the answer. So it's interesting actually, the most popular answer was the one-off directive. Right after that, the different stream. And far behind are fragment arguments and client controlled navigability. I know you have a lot of opinions on each of those. Maybe you can describe very quickly just what is each and why do you think they matter?
Yeah, sure. So the one-off directive is therefore actually solving the problem of input unions. So basically, if I have a mutation today and I have an input type, there's nothing like in union, and that's why there is this proposal of the on-off directive. So you can annotate your input type with add one-off, and then you have basically input unions. For different stream, it's basically probably also my favorite one, just to tease a bit, is that you, like with GraphQL, we had this thing, first we had different endpoints, like single endpoints for fetching data, and people wanted to put it into a graph and fetch everything together. But then they realized, oh, no.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire.
Really, really exciting and great to have you here. And of course, I'm really excited for everything that's coming to yoga, but I'm very, very biased here. Yeah, thanks for the talk. Cecilia, over to you.
Thanks for having me.
Great, thank you so much. Awesome. Well, I'd like to thank our platinum sponsor, Neo4j. Neo4j is the world's leading graph data platform. It delivers real-time transaction processing, advanced AI ML, and data visualization. You can learn more at neo4j.com. All right, so I'm super excited to welcome Lucas Ledbetter, Solution Architect at Apollo, with his talk, GraphQL won't solve your performance problems, but @defer might help. So Lucas is a solutions architect at Apollo, working with companies on GraphQL implementations at scale. Prior to his time at Apollo Graph, he worked at Twitch, helping game developers bring new experiences to the site. When not working, he spends his time gaming and exploring New York City. So as with our other speakers, Lucas has a question for you. So we can go to Slido 0812, and we can take a look at the question, which is, how do you currently handle slow fields within your graph? And there's a couple of options that you can choose from. You can wait for the response, split the query, prefetch when possible, or using defer or other. So make sure that you go to Slido, answer the question, and we will review the results with Lucas after the talk. Also, don't forget to ask questions on Discord in the Andromeda Q&A channel. Lucas will be available for Q&A after the talk to answer your questions, so make sure you post them and don't be shy. So let's give a big round of virtual applause and welcome Lucas. Lucas, the stage is yours.
Hello everybody, my name is Lucas Ledbetter and I'm a solutions architect here at Apollo. I'm extremely excited to be here today, at least virtually, to talk about the defer directive and what it can mean for your clients. To get the full picture, we'll need to cover a few background details before diving into what defer actually is. Lastly, I'll give a few examples showing why defer can be an incredibly powerful tool in your arsenal to help your clients give a better user experience. So to take a step back, you might be aware that GraphQL requires the entire body be sent as a single response. This is great for most queries, as your UI expects all data to be there. You certainly wouldn't want to return only some of the data for a user on a user profile page, for example. As your graph grows, you realize not all fields are built the same. Some fields require additional time to resolve for one reason or another. For many organizations, this is simply due to scale, but for others, it can be tied to a third-party service that they may not have full control over, thus are beholden to the other party's response times, or a number of other reasons. Regardless of why it takes more time, they realize that the requests for those fields cause the entire response to slow down. As clients begin to access those fields, they start to see the overall graph latency increasing as a result, which isn't ideal and means the user experience is impacted. The client should be able to partially render data as it comes in, but is unfortunately not possible with a single request. So to solve this growing problem, companies came up with two different approaches. Both address some of the problems, but each came with trade-offs. The first solution we'll cover is query splitting. This solution was to split the single query into multiple queries and required clients to orchestrate the responses. This sounds a lot like one of the problems that GraphQL was built to solve for. However, this addressed the weakest link problem that plagued traditional GraphQL until performance problems could be mitigated or addressed on the server. In addition to having to handle the responses on the client, it also required the server to handle multiple unique queries from the clients, each with traditional HTTP and GraphQL overhead, as well as being unable to use already fetched data, such as a parent data type. Losing that additional context, especially for fields needing to make many calls to other services, could be quite expensive. On the other hand, prefetching became another popular way to address this problem. By requesting data ahead of time, it is possible to mitigate performance concerns by making assumptions about the user's intentions. For example, grabbing the user's payment information prior to hitting the checkout page. This had the added benefit of it still being a single request. However, the user's experience on the client doesn't change much, if at all, when it works. As might be obvious, servers are required to handle this additional load for assumed interaction, even if the user never interacted with the returned data, making this mostly informed guesswork. Both of these solutions made progress towards the end goal of a good user experience, but never got there all of the way. That takes us to the defer directive. As you might have guessed, defer is a possible solution to the ongoing problem of higher latency fields while still having a single response. The first question you might ask yourself is, what is this defer directive thing? And it's a great question. Defer is a directive used by clients to inform GraphQL servers that the request can be delivered incrementally by specifying parts of a query that can be returned later, or in other words, by deferring the response. As of today, this directive is not part of the official GraphQL specification. However, it's been used by a number of companies in production already. It is currently under the working group with a publicly accessible RFC, which covers the ins and outs of the directive, and I'll have a link to the RFC at the end of the presentation. As a quick sidebar, we've all seen directives used in server-side applications, from formatting information to Apollo Federation notation and more. But the GraphQL specification also calls out the ability to use them in the query itself. In general, I'm a big proponent of executable directives, or client-side directives. They allow for clients to provide additional context to server for use in processing, and not simply notation in the schema about expected behavior as with server-side directives. We've seen client-side directives in the past with things like skip and include, as defined in the specification, and defer is much the same. So why do I bring this up? By making defer indicated by the client instead of the server, we can now let the clients inform the server of what fields can be responded to later and which ones cannot. Not all requests are the same. It may be okay to defer portions of a query in one component, but that same query may need to be returned as one response in another component. That context is hard to convey without defer. So now back to regular scheduled programming. So how does this directive actually work? Is it magic? Well, it's not magic, but it might seem like it after working with it for the first time. We'll be covering this at a high level today for the sake of time, but there are excellent talks and posts covering the more technical aspects of the directive, as well as the RFC from the working group. So consider this basic schema for a fictional social media site, which has a query to return a list of users, as well as a user type with a list of friends. In this example, the company running this GraphQL schema notices that the friends field isn't as performant as it probably should be. I want to explicitly call out something here, however. The friends field, while returning a list of non-null users, is itself nullable. This is important, and is something we'll touch on in a bit as to why that's the case. Now, given the query on the left to fetch the list of users along with their friends, we send the requests, and it takes a second for the entire response. This isn't great, and as a client developer, we could render the user data partially before rendering the list of friends for each user. On a user profile, we probably render their username, contact information, and more. Well, the friends list can load when it arrives, instead of blocking the entire rendering process. So we've now modified the query to include the new defer directive. You first might note that the directive is on an inline fragment. This is because the current RFC states it must be included only on fragments or inline fragments. Now if you execute this query, we get back a multi-part response shown on the left. The first response has a new field, but otherwise contains the same structure as a normal GraphQL response. Subsequent responses have a new format. While it's not critical to understand all of this, there are two parts I'd like to highlight. First, each response has the hasNext field, indicated in blue, which indicates to the client that there are more responses coming. Once it's false, the entire response has been sent. Each subsequent response has the incremental field, which contains the delta and path to the additional data. As you can see, the additional info here is inserted into the user's array at index 0. Now, to put it together, here's a short GIF of the results. You can see we get back an immediate response in about 8 milliseconds with basic data, and then a second later, we get the remainder. If you're curious, the GIF is from Apollo Sandbox, and supports defer out of the box now, including a nice timeline to scroll through the various states of the response, and could be a helpful tool to understand how your deferred response is happening. So as you begin to think about defer, you might notice that it doesn't actually improve performance. You're still waiting for a response after all. But to really dive into how it can help, you must first ask yourself, why do you care about performance? This is a question I have to ask a number of companies to answer for one reason or another. For some, it's measuring how third parties are performing within their graph. For others, it's about how the user experience is going. Most of the time, however, The reality is that users are the most impacted by performing graphs. Many client teams measure against time to first byte, time to interactivity, payload size, or any number of other metrics, but Defer specifically targets time to first byte and can assist with time to interactivity, depending on how it's implemented. So let's look at a few examples of Defer in action and talk about how they can improve the user experience. We'll first want to look at a relatively straightforward way to leverage Defer as a way to do partial rendering or lazy loading. Going back to our previous schema, we have now added a few more fields to the fictional social media site. As mentioned earlier, we could probably render the user's profile information quickly before adding in friends later. Now, we'll see the two queries side by side. Note that we've added the avatar URL, username, and title of the base query in both, since we need that right away. Otherwise, we'll defer the friends list, same as before. Now, excuse my terrible mock-up. I'm most certainly not a UX designer. In the normal query, we're blocked by its lowest fields, which is in the case the friends field, and we can't render any other data until it's finished. But you can see right away that we get the profile information in the deferred requests and can clearly see that we get our data quickly. Our time to first byte has dropped significantly, and probably even more importantly, time to interactivity is decreased as well. The user can see and engage with parts of the data before the full response is sent. Now, going a step further, perhaps our company identified that the friends field wasn't or slowed down based on the number of friends selected for whatever reason. There's another potential path we could take. We've now added two new parameters to our friends field in the schema, shown on the left, to allow us to specify the number of friends to show and an offset. Using Defer, as well as GraphQL aliasing, we can now load the first 10 friends quickly, and then offset the remaining friends in the deferred statement. Traditionally, this would consist of multiple queries to fetch the other friends to render. Allowing the server to run these queries in parallel gives other performance benefits beyond simple UX improvements. In fact, this is quite similar to the stream directive, which is a part of the same working group as the defer directive, but falls a bit out of scope for today's discussion. In summary, it uses much of the same patterns as defer to send large lists incrementally, with an initial list of items sent across. Each subsequent chunk in the multi-part response would then contain additional entries to the list until finished. There are a number of great talks and documents about Stream, and I highly recommend taking a look at it taking a look at the RFC for that directive if sending large lists is a concern for your organization. These sorts of optimizations are enabled by using Defer, and so as you go down the path of considering Defer as a solution, consider how you might also leverage other aspects of the GraphQL to layer features together. You'll likely realize you can create solutions with deferred returns that weren't previously possible, and can help with improving client-side performance. Note, that's also possible to have more than one defer or even nesting defers. In this example, we have a user which has a company profile associated with it. That company also lists their owner. In this case, it's quite possible that the user's service communicates to the company service, which then goes back to the user service to resolve the owner information. These hops take time, and in this case, we can defer each step to start returning data along the path, rendering data as it comes in. It's quite possible that the company name isn't immediately critical on a profile, and the list of owner isn't probably important at all. Now, let's consider some other potential UX improvements. Fetching data is pretty straightforward. We can all envision how to do partial loading since there was a solve prior to defer. We'd simply use multiple queries or queries per component in React. But what about changing data? Mutations are in GraphQL as well, and thankfully, Defer supports mutations as well. As an example, here's a sample mutation for a fictional payment service. Breaking this down, it returns a payment ID and a user, as well as a payment status interface. This interface either indicates success or failure states. As a side note, I personally love codifying errors and schemas for things just like this, and we'll actually touch on errors in just a moment. Diving a bit deeper into this, for folks that work with e-commerce, you know that payments can take a while. Defer affords us the ability to return a transactional ID, which we can use for later, such as the user refreshing the processing and otherwise show a loading screen. Once we've gotten a result from the payment status field, we can then render appropriately. Either it's a success, in which case we have the build amount, or it's a failure, in which case we have the message, or reason in this case. From a user perspective, however, we can properly render the right result without subscription or polling to get an updated status. Instead, we use the existing HTTP connection to forward the information to our clients for use later. And as much as I love talking about codifying errors in your schema, and shout out to Sasha Solomon for her excellent talk on the subject, errors are a fact of life. As much as we strive to build error-free code, codify all the various error states in our schema, and make tests to avoid them, they happen. And as we start discussing performance, errors are a natural topic of discussion, since they are also a measurement of success and user experience. With that in mind, you might wonder, what happens when an error occurs during a deferred statement? Well, to see, we have this certainly not at all suspect query to return definitely not an error in a deferred statement. I mean, who could have seen that coming? But in all seriousness, errors and defers are strange. The best analogy I have is that they're much like JavaScript promises. You're pushing the result to come at some undefined time in the future and have to check to make sure that's not been rejected, or errored in this case. So for the client teams watching this, it requires you to think about partial error states as well more carefully. Previously, you might retry the whole request if you saw an error. But in the world of defer, you might have a success state initially, but an error state late in a request. So you should consider your retry strategy on a case-by-case basis. To demonstrate this, on the right we have a GIF of Apollo Sandbox once again. You'll notice immediately we don't have any errors, and then one comes through and matches the format we already saw. Looking through the timeline, we can see the first response was excellent, no errors, but the second reply does have an error. And this expands with multiple defers. If you have two deferred certain statements error, you get multiple errors in the error key, as you would in a normal GraphQL response. And to briefly touch on some considerations you should have as you use defer around errors, we recommend codifying any expected error failure states, such as user not found, into your schema whenever possible. This creates a cleaner experience for your client teams when they get failure states in a deferred fragment, avoiding them having to parse through errors. When you can't, however, expect everything in the kitchen sink. Be ready to handle errors within your client by checking throughout your deferred responses to see if you run into errors. Lastly, if you give back partial data, use that partial data and don't kick a user off the page if one piece fails to load. As obvious as this sounds, defer is best used for lower priority data, things that can wait to be returned. And as such, retrying or other mechanisms can help make sure the user experience is still excellent. And if you recall earlier, I explicitly called out that our social media site's friends field was nullable. Defer supports both null and non-null fields, but the behavior of errors differs depending on how you use defer and how the field is typed. This differs from traditional GraphQL, so it's important information to know. Our friends list was a nullable field with a non-null list of users. The query we used before is great. It's likely that the request would be an all or nothing request, where if we fail to get to friends for one reason or another, the field will remain null, as you can see here. Great. Now what happens if the friends field was non-null? In a normal query, we get back an empty data object since a non-null field returned null. Now, how about deferred statements? You might expect that the same would happen. However, we get back a partial response without the friends field, but including the ID field. This is an important aspect to consider when dealing with deferring clients. The error behavior changes from traditional GraphQL, and you must be aware of this change when migrating to using defer in your queries. The same also applies when deferring specific fields. For example, we have a query to get a user and their avatar URL, which comes from a service that isn't 100% reliable. This field needs a response, however, so we marked it as non-null so clients can expect it to exist. Same as before, query on the left is not deferred. And as expected, we get back an empty data object. Now for the defer, we get back the partial object again. So with all of this in mind, my recommendation is this. Be careful with nullability, as defer introduces additional complexity when it comes to the response. Just be aware that this exists as it currently stands in the RFC, and you'll be okay. And while we talk about what defer is and how you can use it in principle, to use it in practice is thankfully fairly straightforward. Apollo recently announced support for defer in both their React and Kotlin clients, with iOS support coming soon. For developers considering defer, this can be a massive help if you're currently using Apollo's clients, since defer can plug into existing applications without headache-inducing rewrites. And once you have a client that supports defer, you simply need to rewrite your queries with defer in mind. As mentioned earlier, Apollo Studio and Apollo Sandbox can be great ways to test defer and see how it works in your graph and ensuring what it does what you expect. In fact, that's what you're seeing on the right. It's the nested defer example from earlier. Apollo has also released a version of defer for organizations using a federated graph, and this is especially unique since it doesn't require any support beyond being able to resolve federated entities. I won't have time to dive in deep here on this, but the short version is this. If you're using Federation and have even a remote interest in defer and what it can afford for your clients, check it out. The implementation is agnostic of library, so even if your subgraph library doesn't support it out of the box, this can enable it, so long as you're using Apollo Router to serve your supergraph. To summarize how it does this, the router leverages the existing entity relationships and manages the asynchronous process of getting the data for you, so subgraphs are not needing to handle sending the responses as multi-part as all. If you don't currently have a federated environment, adding federation and entity declaration, which is just syntax, is a simple way to utilize the router as a way to get defer without much code change on your server. We've seen how great defer can be. It solves a lot of fairly complex problems in a declarative manner, playing to the strengths of GraphQL. but at the same time, consider the experiences you drive currently and what use cases might benefit from being deferred. We've seen examples of how to do this. One where it was a drop-in fix for the team, and another where the schema needed to accommodate defer to provide a better client experience. Keeping in mind those experiences can ensure your schema remains expressive, while still enabling defer as an option to improve user experience. Finally, as mentioned before, defer is driven by the client. They will be most aware of what use cases can be driven by defer. We've seen that defer is best used for lower priority data, so simply stuffing a query full of defers will provide little benefit. Make sure defer is used carefully, and ensure it makes sense to do so when you do use it. And while you can improve the user experience and client-side performance, defer isn't a panacea. It won't solve your server-side performance concerns, and it should be treated as such. Identifying and resolving server-side performance issues can also remove some of the need for defer, so doing both can help your graph seem and be more performant for clients and servers. And so a few parting thoughts around this. First, defer is a powerful tool for your consumers of your graph and should be leveraged if possible. There are a menagerie of ways to improve your user experience using it. And to that end, while specification is new, there are a few libraries that already support it, and Apollo recently announced support for organizations using a federated graph, as mentioned previously. And my last point today is this. If you are interested in defer, but it doesn't meet your requirements or you feel like it can be improved, get involved. The GraphQL community is deep and wide, and the working groups can always use more feedback about specific use cases, concerns, or more. Get actively included in if you can. Lastly, just some resources as mentioned. We have the link to the RFC, Cecil Solomon's talk, the 200 OK talk about codifying errors in your schema, docs for both Apollo React Client, which was used to demo defer earlier, as well as the Apollo Router Federation defer support. With that, thank you. You can reach me at LLedbetter on Twitter, and that's my email, lucas@apollographql.com.
All right, thank you so much, Lucas, for that super interesting talk. If you can go ahead and join me on stage.
Hi, everyone. Nice to meet everyone. Thanks for joining today's talk.
Awesome. Thank you so much for being here. So just a reminder to everyone, you can join the Andromeda Q&A channel on Discord to ask your questions for Lucas here in this Q&A. But let's go ahead and get started by taking a look at the answers to the poll question. So again, the question that we had was, how do you currently handle slow fields within your graph? And it looks like we have a pretty overwhelming, strong response for just wait for the response. A little bit behind that is split the query and prefetch when possible. But Lucas, what do you think about the results? Is that in line with what you expected?
Yeah, for sure. I think in general, we see a lot of companies doing this where it's not currently feasible or possible to orchestrate the responses to handle split queries or making assumptions about user interaction, may not have data there. And so in general, it's really just we wait for those slow fields to show up and then render when we get it.
Yeah, and just to answer a question here from the audience, does defer replace?
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it
Slides as well.
Awesome, great. And just to reiterate, where can people find you on Twitter, Lucas?
It's at L Ledbetter. My last name's a little bit long, but it should be in the slides. And then my email is just lucas@apollographql.com.
Perfect, awesome. Well, thank you so much for being here, Lucas, and for answering our questions and for the super interesting talk. We really appreciate you being here today.
Yeah, thanks for having me.
Great. All right, so now we're going to have a short break. It's time to grab some tea or some coffee. We will continue. We'll be back here in a couple minutes. So stay with us, but feel free to grab a drink and then join us for more really exciting talks that we have coming up here at GraphQL Galaxy.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Hi everyone, welcome back to GraphQL Galaxy 2022. I hope you had a nice break. I hope you drank coffee or whatever it is that makes you a bit more awake. We have many more interesting talks and conversations, especially the next one. But just before, I wanted to thank our gold sponsor, StackHawk. StackHawk makes it easy for developers to automate security tests against JavaScript apps and the backing GraphQL APIs to find and fix security bugs. You can visit stackhawk.com to learn more. And now for the next speaker, or AMA, which I'm personally really excited about. I'll introduce him, even though I'm pretty sure he doesn't need any introductions. This is Lee Byron. Lee is the product engineering lead at Watershed, building tools to help companies run climate programs. Prior to that, he led web engineering at Robinhood and worked on product infrastructure at Facebook, which you already probably know, where he had a hand in open source libraries like React, Immutable.js, Flow, Relay, Data Loader, and of course GraphQL, which we all love and use. He started and directs the GraphQL Foundation, which today supports the GraphQL project, which we probably will also talk about today. So welcome, Lee.
Thank you all.
Yeah, it's great to have you here. We asked Lee to ask the audience some questions that you can answer on Slido while we do the AMA. And the main poll question that he asked, which I think is a great question, is what is a new non-GraphQL technology that you are the most excited about? I think it's a great question. So thanks, Lee, for joining. I'm really excited for our AMA. And let me start with maybe the first question. Which probably you're one of the best, if not the best person to answer this. How did GraphQL start? What's the origin story of this, and how did we all end up here in this weird conference?
Yeah, this is a throwback because this was, at this point, over 10 years ago, which is kind of crazy. To kind of set the stage, two things were happening at Facebook at this moment. One was our sort of monolith code base that served Facebook.com was doing a migration from early phase PHP code base to more structured with great product infrastructure. We had this sort of ORM-esque kind of layer that we called Ents, and we're starting to introduce type systems into the code base, and that was creating this sort of very amazing abstraction away from underlying systems and data storage, and you could just sort of interact with these high-level objects to get the data that you needed to put together any particular web-based product that you were doing. This was great. Another thing that was happening was the move to mobile. So Facebook, of course, started as a desktop web-only platform way back in 2003, 2004. And from there, slowly made its way into mobile. The first kind of cracks at mobile were, if you remember, WAP, the like HTML variant that was all black and white and had no images, like that for flip phones. Like I think that was the very first version of Facebook for mobile. And then that sort of evolved as devices evolved, and we sort of followed the inertia of that. And that meant that all mobile development at Facebook for many years was really web only. There was an iOS app, but it was super limited. It only basically you could look at your newsfeed, and that was kind of it. And eventually even that got replaced with the full web app. There's sort of a wrap around it. And it sucked. It wasn't great. Like the performance was bad. We tried to do really cool like animations in the the internalized browser, and it would just consume all the RAM on your device, and the app would crash. So it was slow, it was buggy, it crashed a lot, and basically the web technology, at least in that moment, was not growing and scaling, developing at the pace that we needed it to. So we had created a project to go back to native development. And this was in 2012, which was still relatively early for native mobile engineering, but sort of clean slate, new project, and Xcode style, started creating a new iOS app. Had a little skunkworks team of 3 or 4 people, iOS developers, building this thing. And they realized that they just couldn't get the right data that they needed, because all of Facebook's development to that point was basically just like stuff happens behind the scenes in PHP, and then HTML comes out the other side to serve a web page. And not a ton of thought had been put into an API, not as sort of like a partnerships thing. Like we had developer partners on Facebook that used a developer API, but we hadn't thought about a product API. Like what would it look like to build a true Facebook product on top of an API? So I happened to be supporting this team at the time. There were engineers that were working on my team. And they were bounced into this problem. We're like, all right, well, let's go dig around and see what we can find. And we started looking at various APIs we had built before, and they were all kind of underwhelming. And there was this new one that we had built called FQL, which was sort of a variant on SQL, but was layered on top of this new ORM system that we had built, these ents. It was really exciting, but if you've ever had to write like a join between like 6 tables, just like brain starts melting. And basically we would write these FQL queries that only maybe 2 people at the whole company could interpret, and they were like hundreds of lines of SQL to write these join queries. It was like, this is nuts. Like, I don't think SQL is the right tool for this. There's got to be a better way. And so went to the author of Ent, which was Nick Schrock, who was sort of galaxy braining this idea that what if you could write PHP that wasn't PHP, but was like kind of looked like PHP, and then you could send it to the server. And because it was almost PHP, you could basically just evaluate it, but it wasn't really PHP, so there wasn't the security risks. And basically was inventing a new programming language for doing like cross internet, almost like a multi-phase RPC. So this was super exciting. He called it Supergraph. And we were also, of course, in building a new version of Facebook, we were working on Newsfeed first. So we went to the tech lead for Newsfeed, which was Dan Schaefer. And he was in the middle of migrating Newsfeed, which is one of the oldest code bases of the company at the time, to this new Ent layer, adopting the new best practices within the company. And then my team was trying to figure out the mobile stuff. And so the 3 of us sort of got into a room, and it's like, okay, there's got to be some elements of the 3 things that we're working on that align. And then we basically just like didn't go home for a week straight, which like couldn't stop ourselves. We got so excited about this. And in a couple of weeks, we had a prototype working that was basically half of what you would use in GraphQL today, with a language and a parser and an evaluator, and it layered on top of ents. And so in that sense had resolver functions. And it worked, and we handed it to our iOS engineers, and they were super excited about it. They started using it, and it did everything we needed it to do. We shipped that new version of the iOS app with Newsfeed on top of it, profile, and the rest. And actually that code base, that lineage of the iOS app is the one that exists to this day. If you use the Facebook app, that's the same origin code base that you're using. And obviously the GraphQL infrastructure there has evolved considerably over that time, but to this day, GraphQL is the way in which that all the data is served to that app. So that's the origin story. That's where GraphQL came from.
That's an amazing story. I mean, for me, even though I know a bit the story, I think it's always very interesting because I think it also speaks a lot. There's a lot to learn also for the community. There's a lot to learn from that story today, because like, I think everything you described about basically exposing data from in a way that is structured well for the product. And on top of any basically data source that wasn't necessarily supposed to be exposed, that was written to being exposed to the, and how you solved it. I think today that's probably one of the reasons why GraphQL is so popular, or at least, you know, what I can see as well, like in the day-to-day, like people are really excited about GraphQL because of that. So basically, you know, you set out to maybe solve this for Facebook specifically, and you ended up solving it for, I think, countless companies around the world. So thank you. This is really exciting.
Yeah, the latter is very surprising to us. I think we kind of saw it as exciting, but it felt complicated to us, and which made sense for sort of the surfaces of product that we were building, which were in fact quite complicated. And it took some convincing and quite a lot of simplifying energy went into the variant that ended up getting open source, which is quite a lot better than the one that we had started with 10 years ago. Yeah, pretty wild.
Yeah, I think, it's not only that you created something so valuable, but also that you managed to open source it, which is never easy in almost any company. So, you know, once you open source it, I wonder, you know, GraphQL basically exploded, and there's so many today companies and different solutions and different things that our huge community is using. I wonder, you know, when you look at everything that happened, what are the things that you actually predicted or thought, oh yeah, that was supposed to happen? And what are things that you were like, whoa, I didn't expect any of this to actually happen, or like, and that could include where it end up with, or maybe even use cases that like you never thought happened.
I think I've been impressed and surprised by the majority of the growth of the project and everyone who is using it, and everyone's using it in really interesting ways, in ways that initially I thought would be maybe inadvisable or kind of nuts, but have actually ended up being like very interesting. I think there was some talks before about applying GraphQL over graph databases, and this was like FUD that we had to clear very early as people looked at GraphQL and they thought, oh, because it has QL in the name, it must be a database language. And I already have a database. Like, don't make me replace my data. Like, no. We don't want you to replace your database. It's just purely a orchestra. All it does is calls functions under the hood. It's there's no database here. And so as soon as we heard people are going to use this atop graph databases, we're like, this is moving exactly the opposite direction of the FUD we're trying to clear. And this seems like probably not great, but actually ended up being incredibly interesting. And there's like a separate line of thought around when we open sourced React, and not too long after that, we saw Ohm, which was sort of the combination of React and the ClojureScript environment. And ClojureScript is just action-packed, full of super interesting ideas that really deserve to break out of that ecosystem, but sometimes struggle to, just because the environment is so, like the Lisp environment is so different. But one of them is this idea of pull queries. And it wasn't until after, I mean, of course, GraphQL is in its package new, but it has a lot of ideas that are not new. And that was one that was sort of surprisingly aligned. And another very interesting thing that we're seeing is like influences between the two. Another one is just seeing the number of people who are adapting and expanding GraphQL to new languages, new domains, and new environments, new use cases. I want to say I expected that. I hoped to see that. And the sort of speed at which that occurred was faster than I thought would happen, which was great.
Yeah, I think so. As someone who runs, and like I said in the introduction, basically manages the GraphQL Foundation and the GraphQL working groups, what in your mind are like the most interesting things, the most exciting things that are happening currently in GraphQL, and also maybe how people can join or hear about it more?
Yeah. The GraphQL Foundation is super fun because there's sort of two ways to get involved. You can get your company involved, which is a great way to sort of like have a little bit of influence over the overall direction of the project at large. There's a financial element to that. That is how we help fund the project being healthy and successful. But you could also show up as an individual, which is completely free. You don't have to do anything. You just show up to our working group meetings, and you can participate in the development of new features to the GraphQL language as a whole. And I'll give you a boring answer and then an exciting answer to this question, because, and maybe this is like the wonkery of me, is one of the things I find very exciting is just the enthusiasm people bring to the smallest of problems, because the smallest of problems multiplied by an incredibly large number of developers who use GraphQL is actually extremely important. And so people sweating the details and really making sure that the quality bar is extremely high. So you'll see topics pop up that like unpack small discrepancies in the spec that were manifested via a bug that they found. Like they found a bug somewhere and they worked backwards all the way to the point where they realized that there was ambiguity about what the right answer should have been. And then they fixed it all the way in the spec and then worked it all the way forward again. I love that. That's the thing that gets me excited. But then in terms of sort of new surface area to GraphQL, it's got to be defer and stream. So this moves GraphQL from being a transactional thing to being a live thing that happens over time. And we have one version of this, which is subscriptions. And this was probably the biggest change since open sourcing it. And that happened a number of years ago. But that is more about given an event stream that occurs somewhere under the hood, an event occurs, and then you still do sort of the transactional thing. Like you run a GraphQL query every time an event occurs on some event stream under the hood. But defer and stream lets you say, given a particular set of data that you need, a GraphQL query, you can kind of get it streamed to you over time. An array of things could come back in chunks, or there could be a fragment that you say like, I need this, but not immediately. And so if it takes a little bit of time to prepare, I can defer it. And that is extremely difficult to get right. Asynchronicity creates a ton of corner cases. And the folks who've been working on this have been doing a fantastic job pressing at the edges and making sure that it's going to be great. And I'm very, very excited to see what this does in terms of unlocking sort of new development models, especially as I'm watching the development of React and other open source front-end libraries, which are also sort of embracing this idea of sort of continuous data delivery and continuous UI rendering as like a thing that gets merged. These two things go hand in hand, and I'm really excited about that.
Thanks. Yeah, this is really, really exciting. I think I get to talk with you a lot and get to hear a lot of talks from you. And I think I always have, now that the fact that I can ask you a question in the AMA, I always ask myself, you know, you were in Facebook doing all of this and creating it and inventing it, opening to the world. But then you also now have the experience after, you know, later you moved to Robinhood and now in Watershed as a product engineering lead. Like, how is your personal experience of Graph? And you're doing, you know, I think, you know, we all, you talked a bit about what's happening and how you manage the community and the big stuff that are happening outside in the community. But it's interesting for me to hear also from your personal experience after leaving Facebook and going through a couple of different phases. How is and if your day-to-day with GraphQL today, how is it for you? What are you using? What do you see? If at all, or
yeah, we use GraphQL at Watershed. It is the way in which we move data between our backend service and our front-end client, and it's great. It's a super different use case from Facebook, which has this massive schema and it's super challenging and needs a ton of infrastructure, to Watershed, where we're trying to approach it as minimally as possible. We have like one file that defines our whole schema and one file that pulls in all of our resolvers, and then that's kind of it. But nonetheless, it does feel more complicated than I want it to feel, even in the approach of trying to sort of do the minimally viable infrastructure around it. It's working very well for us, but you know, one of the things that I think is a yet unsolved problem in this space, and I really hope someone can crack it, is to take code generation out of the puzzle. Using GraphQL with code generation is fantastic. You can like generate your TypeScript types or your Swift types or whatever front-end client environment you're using. But it introduces this step, and it's tough to, you know, edit code in one file and then immediately see your environment updated in another file. And there's this other thing you have to do that feels like a one-off. And I don't know how to solve that problem, but that's the one that if anyone has got like a super crazy ambitious idea, is how do you make integrating GraphQL into your IDE environment and making the code generation step disappear into the background? I think that would make things feel much smoother.
Yeah, I couldn't agree more. I think, and this is for us also, by the way, this is a problem or something we're looking at both at the backend and the front end, right? Like the backend, you have code first libraries. I think the latest one that we are most excited about in the JavaScript, the TypeScript world, is Potus. I don't know if you had the chance to look at it, but it's very exciting. And it actually skips the whole code gen process. And on the front end, I think there's a lot of new things, like things that are also code first. There's all kinds of different solutions out there, and we're actively looking into what are the possibilities there, but also we're researching some of the things are also limitations on TypeScript, but I think there are some works in it. So yeah, I'll join your shout out. So if someone
there's
is
promise.
Exploring it, yeah, there's promise. And like if someone wants to work on this, ping both me and Lee at any time you can. Thank you, Lee. This was fascinating, and thank you so much for joining me. For the folks at home, you can go to also the Andromeda channel on Discord and ask questions, and Lee will be there as well. Yeah, and thank you so much. And back to you, Cecilia. Thank you, Lee, for joining.
Thanks all.
Great, thank you so much for that amazing session. So we do want to see Twitter full of today's event. So make sure that you are showing us how you're watching with the photo and tweet it with the hashtag GraphQLGalaxy. We'll be keeping an eye out for your tweets, and we'll have a raffle of multi-passes to Get Nation conferences and t-shirts. Additionally, don't forget to join our discussion rooms in Spatial Chat tomorrow, December 9th. We will be discussing federation, security, specification updates, and GraphQL clients. So remember to join the Spatial Chat tomorrow to check that out. So up next, we have Phil Pluckman, and with his talk, Finding Your GraphQL Groove. Super excited for this one. Phil is a JavaScript, React, GraphQL engineer and open source maintainer for Urkel style components and several experimental libraries. So Phil does have a question for us, and you can go to Slido and fill out the question. Again, that is 0812 for the code for Slido. And the question that we have is, how do you feel about GraphQL in one word? So definitely make sure that you fill that out, and we'll take a look at that result during the Q&A. Also, don't forget to ask questions on Discord in the Andromeda Q&A channel. But let's go ahead and give a big round of virtual applause and welcome Phil. The stage is yours.
Hiya, I'm Phil, and today I'm here at GraphQL Galaxy to talk to you about finding your GraphQL groove. This talk is a bit of a perspective from myself on getting started in today's ecosystem, what you might encounter, what problems I've seen people encounter, and what it means to use GraphQL today. A bit about myself, the usual socials. You can find me under Kitten on GitHub or @_PhilPL on Twitter or on Mastodon if that's your thing. I currently maintain Urkel with some other people, and Urkel is a GraphQL client that was originally founded by Formidable and supports frameworks such as React, Preact, Vue, and Svelte. We're currently working on Onoko, a supporting team that will basically full-time maintain this project. Currently, what we've seen in the last year is that Urkel has grown a lot, and that corresponds to the growth of GraphQL overall. Not only is Urkel growing, but if we're looking at Apollo clients number, we can see that similarly the numbers are only going up and GraphQL is becoming more popular. More people than ever are adopting GraphQL and onboarding on top of it. This kind of leads us to a couple of problems, and I get a lot of questions around Urkel, I get a lot of questions around GraphQL, and typically these problems aren't really new to me. But at the current maturity of GraphQL, I'm asking myself about some of these questions, why are we still struggling with easy problems? And nothing answered that better than the State of GraphQL survey 2022. In that survey, they've basically asked people to answer a host of questions and measured the popularity of libraries and happiness with the ecosystem. But they also had a section around GraphQL pain points, and people could vote on several things on what they currently find painful in the ecosystem. If we look at that, we see a couple of common points that might not be too surprising. We see people deal with error handling, and that's painful, performance problems, client caching, and so on. What I find surprising here, though, are a couple of these points I really wouldn't expect to see at this point in the ecosystem. So we see people are struggling to get the API maybe to be performant. They're struggling with schema stitching and versioning. And I find that worrying, but at this point, I'm a bit surprised that we haven't moved on from these problems and don't have good answers for them. GraphQL, of course, also has strong points as well, and the State of GraphQL survey measured that. And similarly here, we see very strong selling points that you would find in any introduction to GraphQL. For instance, type safety at the top, introspection next. But it's a couple of points here that I'm worried about. Overfetching is still seen as a major strong point that GraphQL solves. However, overfetching is not even a core principle of what GraphQL aims to solve. In fact, I see it as a core problem that any well-architected API should probably address. We also see schema stitching here come up again, and this is quite interesting, as it means that a lot of people think schema stitching is both a strong advantage of GraphQL, but also a major pain point. Lastly, we see community as the very last point on strong points in GraphQL. And years into GraphQL, and with many different options to choose from, I find it surprising that people struggle to see the GraphQL community as welcoming as it should be. As you're entering GraphQL, I think you're following a very similar trajectory as many other teams are, and that you start out thinking that GraphQL's value proposition is very exciting and amazing, and you're looking forward to solving your problems. Later on, you might ask yourself, okay, now I want to get started. How do I set myself up for success? How do I get my team to succeed? Things get a bit troublesome afterwards for most people. You're asking yourself questions like, am I getting value out of GraphQL in general? Or are you really finding the right tools for the job? And later on, a lot of teams I found are regretting a lot of early choices and are making small adjustments. Mistakes were made. At this point, people are going back and review their decisions. This talk has been a bit difficult to write in that I see a lot of different people enter the GraphQL space. Very different teams might get started at any given point in time, and everyone has different expectations from GraphQL. And many teams probably also run out of time trying to fix their problems and leave the space before they can communicate what they needed from GraphQL. To go back to these 3 different points, the questions that I want to pose is, okay, what is GraphQL's value proposition? If you're now entering GraphQL and you're probably at this conference because you either want to use it or because you're already using GraphQL, what is it that you want out of GraphQL? And how do you set yourself up for success if you already know what you want? And then lastly, how do I stay on the happy path? GraphQL can be very overwhelming, but how do I stay on track to use it well? The first question, I think, is what everything kind of revolves around it. Why would I use GraphQL? And that's what I want to start with. I think GraphQL has a different value proposition for a lot of different people. And I think we have to look at 2 axes here. We have to use an axis that shows us how front-end people think about it, or how you think about it when you're looking at your front-end stack, and how a back-end team might look at it. But GraphQL also changes depending on whether you look at small or large organizations, small and larger teams, or even multiple teams working on it. The difficulty here is that you will be in a different place than anyone else. Most points on this axis will pose some problem in some form, and you might have very different questions depending on where you're at, depending on whether you're very front-end focused and you're a smaller team, or a larger team that has a lot of backend services. In any situation, you might already still be convinced to use GraphQL, however. After all, you're at GraphQL Galaxy. However, this is because GraphQL has very strong answers to basic problems that any API face. I've mentioned overfetching before, but a lot of different solutions might actually come from thinking about how can I solve overfetching. GraphQL is not the only answer if you're only thinking about simple problems. And that kind of brings me to the next part, cutting through the GraphQL hype. Why are we actually using GraphQL, and why the reasons that we're thinking of sometimes a bit too simple? And I want to kind of cut this down to the separate parts on this axis. And I want to start with front end, since maintaining GraphQL client, I'm most familiar with that. And when you're looking at GraphQL and front end today, you might find that the value that people are seeing in GraphQL is diminishing, and that people are not as excited as they used to be. We have a lot of options today in boosting the productivity of front-end developers. And when you're setting up a new project, you have a host of options to choose from. You might go with a Jamstack static site generation approach. React server components on the horizon. Loader patterns are popular again, and you've seen those in Next and coming up in Remix. And you have new libraries coming up like tRPC that are making foreign functions easily callable and typed. And the whole value proposition of GraphQL loses its edge if we're focusing on too many different problems that are a bit too small. For instance, if we're looking at these 2 different things, people ask about, okay, is tRPC easier but adds the same value to my project? Or is static site generation so detached from actually needing GraphQL that we might as well use much simpler methods to get our data? And I'd like to kind of go back a step here and say, okay, I think of front-end development in terms of having UI views that are made up of trees of components, and each component has a set of data requirements. If we look, for instance, at static site generation from that perspective, then we can export our views ahead of time, and the data providers like GraphQL disappear on the client side. But this leaves out important points around interactions and use cases, like if a view isn't serializable. So if we're thinking mobile apps or non-web apps, PWAs and so on. The next point is then obviously, okay, but RPC and REST can still solve these problems. What if we just lose the schema and we just use RPC? What do we actually lose if we ditch GraphQL and we are just going input, output, we're getting our data and we're happy? That's the problem. If we're choosing to actually compare GraphQL with data retrieval methods, then a lot of the supposed strong points that people think of when they think of GraphQL disappear. These points might be overfetching, but we might also think about preventing waterfalling requests. We might think of performance problems where GraphQL gives us tools to optimize resolvers. We might think about fragmenting our data, but all of these points can be solved with RPC-based solutions. So if we return to the second idea and we think about the data requirements in GraphQL, I think this is where GraphQL really shines and where the value proposition becomes very strong. If you think of GraphQL as its schema mapping directly to your app data structure, then that is where you're finding a lot of the value that you might be missing if you're thinking about technical problems like overfetching. So the question that I want to ask to anyone that already got started with GraphQL and that got a bit disillusioned when first trying it out in a team was, were you maybe sold on basic problems rather than focusing on the bigger problems and the stronger solutions that GraphQL can offer you? After all, GraphQL is a pretty batteries included spec and runtime and framework. And it can help us write declarative data models. It can help us have a typed schema. And it also, to kind of give an example, goes into a concept I like to say of GraphQL being a lingua franca. Now, one of GraphQL's primary design principles, as is also listed in the overview section of the spec, lists that GraphQL is product-centric. And in that, it can serve as a common language not only technically for the server and for the client and the API communication, but it's also a language that your front-end engineers and back-end engineers can use to communicate what they mean when they talk about data. So the kind of learning I have from that, and the thing that I want to tell as many people as possible, is ask yourself, compared to without it, what will GraphQL do for your team? And if you can answer that question for yourself, you're already in a much better place. And that's when you kind of become ready to have a different perspective on GraphQL's astronomically big ecosystem and the different choices you have to make. And I said earlier, one of the advantages of GraphQL is that it's batteries included. And it is in some senses. The spec has the reference implementation. We get documentation built in. Introspection is a big feature. But we still have to make a lot of choices. And that's when the other axis of small orgs and large orgs becomes very important, because you might make different choices depending on what requirements you have, depending on how large your team or teams are. And you are exposed to a lot of choices these days if you're looking at GraphQL. Even if we're just looking at web and JS first development, you have a lot of decisions to make. You have to choose between different GraphQL clients. So for instance, you might see, am I going to use Relay, Urkel, or Apollo client? You might have to choose a GraphQL server, and you might choose Mercurius, GraphQL Yoga, or Apollo server. You might choose a GraphQL schema builder, and that kind of gives you access to a nicer way of organizing your API. So you might choose Pothos, Type GraphQL, GraphQL Nexus, or GraphQL Code Generator. And that choice might even fall away or change if you're using a GraphQL generator. So you might use AWS AppSync or Amplify. You might use GraphQL, Hasura, dgraph, or GraphQL Mesh to generate an API that kind of replaces some of the manual schema building. And that depends more on your data sources. So these are a lot of choices. And the good news is, while this may seem like a lot, this depends on your team's needs. But there's still a lot of choices to make. You often have a smaller selection of things to choose from, however, if you're considering your constraints and requirements. So your server or client might not be written in JS, in which case all of the backend choices, if you're writing in a different language, might narrow themselves down to a whole host of different solutions, but a smaller set. Or on the client side, you might have a specific UI framework you're working with, and not all GraphQL clients will support all UI libraries and frameworks. Or you have specific runtime requirements on what your client does or what your backend has to do, and not all clients will support that. Normalized caching is basically a requirement that I often see from people, and I've only limited the set of GraphQL clients on that list to ones that have normalized caching. You might also already have specific opinions on how you want to author GraphQL queries, and that might factor into this as well. And Relay comes baked in with some of these decisions. From my perspective as an Urkel maintainer, we see a lot of different combinations, but very fixed combinations in these tools. So for instance, for Urkel, we see, for instance, GraphQL Yoga mixed with GraphQL Nexus a lot. But if you're using PostGraphQL and Relay together, that might be a more tightly coupled choice than others, because Relay has certain requirements on the schema as well, and PostGraphQL has a lot of opinions as well that mix well together with Relay. If you're designing on a client, one of these things you have to do is structuring your queries and data requirements, and looking at how you're building these queries, what kind of patterns you want to apply, is probably more important than specific small features on the client. For example, Relay has, as I just said, a lot of opinions. So it has opinions on how you merge queries and how one view will typically run a single query and hoist and compose fragments together into that. If you're into that, then for instance, take a look at Relay or apply the same pattern to other GraphQL clients, and your decision will become much easier. On the schema builder side, I would focus more on the team structure, and you might have to after all. You might not want to choose any given GraphQL server or any given schema builder because it's technically interesting, but you might want to look at who's writing your schema and who's your schema author, and then fit those authoring practices to the team structure and the schema builder you will choose. Lastly, I want to talk a bit about backend teams, and that's the furthest away from what I do every day, but I have a lot of experience as well building APIs and accompanying people as a consultant through the journey of building a GraphQL API. And if we're thinking about a GraphQL API, we might think about a monolithic GraphQL schema. So this is the kind of structure that we might imagine if we're thinking about GraphQL. GraphQL aggregates some data and combines data from different data sources, be it maybe Stripe billing together with your database, together with some kind of asset pipeline, who knows? And those resources go into your GraphQL gateway, you have a schema and your app accesses that. Of course, other people and other teams might think about it the other way around. They might be thinking about multiple apps they have. Maybe they have an Android, iOS, and a web app. And they're thinking about how all of these clients will in slightly different ways access that schema and then access the resources via that schema. In reality, people quickly find out that it's obviously a combination of the two. You have a lot of different resources that are provided via schema to those apps, and you as a schema designer are responsible for making sure that that access works for all of these apps and matches what they are trying to display. A lot of people get hung up on the idea though of, okay, we have multiple resources, we have multiple services, so clearly we could group GraphQL into separate schemas and then merge those schemas together into a gateway. People get almost paralyzed by this decision sometimes on whether to already go into a more microservices architecture with GraphQL. And while there are different terms for it, and while we could look at separate ways of going about that decision, consider, is it a technical problem whether you want to already structure your GraphQL service as kind of multiple microservices, or whether you have a governance question instead of you have multiple teams that are working on separate resources and separate APIs, and you want them to be still able to work separately. A lot of times I've seen teams struggle with that, and the answer is often you have to set up some governance. And it's worth it a lot more if everyone designs a schema together and comes together to build a monolith first. Even if you're not building a monolith and you're choosing one of these other solutions, then you might still decide that coming together and designing the schema with a centralized team is really worth it in the beginning when starting out. GraphQL monoliths are gateways, so this also opens up to different, easier answers. A lot of people who are migrating to GraphQL are making their GraphQL gateway and access to old REST APIs or old APIs in general. So the other question you have to consider is, where do you want to start using GraphQL? Often GraphQL is a backend for frontend killer, and that can really take over a lot of the functionality of what we previously did with writing purpose-built APIs per app. But you have to ask yourself, do I want GraphQL to go further and replace all of my services past it, all of my old APIs? And often you can just absorb that functionality into the monolith instead. So the problem is asking yourself, what's the minimal architecture that your team can adopt today to benefit from GraphQL? Now, all of these separate categories of problems are basically problems of how do we avoid falling in the GraphQL ditch. All of these problems are very similar in that they're questions you might ask yourself early on, but that lose importance if you focus on making things work today and if you stick to your choices. However, the ecosystem doesn't always have great answers. You might be asking yourself, okay, what happens if I want to move to federated schemas in the future? What happens if I need normalized caching in the future? I need to change my decision on what GraphQL clients to use. And the answer to that is the ecosystem doesn't have great answers for that yet. We don't have all the answers around how to move when you are growing as an organization to new solutions, except for traditional solutions of starting over with some parts. The other side is, clearly I've stated, the client side has a lot of possible opinions and approaches to writing your queries and structuring your app. But that guidance can be pretty unclear. And today only Relay has the most solid opinions on how to structure your app. And while that works for React, and there are adaptations for other UI frameworks, we're still a bit further away from having the perfect developer experience paired with good opinions that are giving you more guidance to build these apps. So when you build your GraphQL API, or if you're getting into GraphQL, what I can recommend to you is for your team, find the largest intersection of features, of requirements, of what you need. Choose the tools and don't get distracted early. A lot of people are happy with GraphQL and productive with GraphQL, be it small or large organizations, because they've made solid decisions, and when those decisions turn out to have flaws, they still stuck with them for a bit to find out what the actual problems were, because sometimes they might be governance problems instead. Now, this is only 20 minutes and that's my talk, but if you have more questions, you can come to the Q&A, or you can contact me on Twitter or Mastodon, or you can go to the Urkel docs instead on this link. Cheers.
Awesome. Thank you so much for that amazing talk, Phil. Hopefully that helps to ease some concerns or questions that people have about working with GraphQL. Phil, why don't you go ahead and join me on stage?
Ryan, hi again. Good to be here.
Thanks so much for being here. Awesome. And so we're going to go ahead and get started with the Q&A. Just as a reminder, you can continue to ask questions on Discord in the Andromeda Q&A channel. Let's go ahead and start, though, by taking a look at the answers to your poll question. This is a fun one. So the question was, how do you feel about GraphQL in one word? It looks like we got some positive responses here. What do you think about the results, Phil?
Oh, that's really positive. That's interesting. We're in an interesting time in GraphQL, and I feel we're kind of on the verge of a lot of things. So I'm glad to see that it's positive. On the other hand, I would have expected at least a bit of negativity. I don't know. Who else hopes for negativity? I shouldn't hope for that.
I think it's good to hope for search for feedback, right? You can always grow when you get feedback. But I guess maybe the audience here today is feeling good about after seeing all the talks and everything. So happy to see it. Awesome. So we can go ahead and get started with some of the questions that we do have. First question is, what is the future of the Urkel?
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
not sure. I'm not sure about that. That's why I was hoping for the poll to be a bit more spicy, a bit more controversial.
Well, if you have any spicy takes for Phil, you can find him online. Reach out to him with any of your constructive feedback. So, but thank you so much for being here, Phil, and for answering our questions and for your really interesting talk.
Thank you for having me.
Awesome, Ori, back to you.
Yes. Hi, everyone. First of all, I'd like to take a moment to thank our gold sponsor, Focus Reactive. Focus Reactive is the Next.js headless CMS and the e-commerce expert agency. They're partners with Vercel, Shopify, Storybook, and Sanity. They deliver quality software with a focus on scalability, performance, and great user experience. So be sure to check them out. Now for our next talk and our next speaker, it's Tanmay, the CEO of Azura. He's a really dear, good friend of mine, and he's going to talk about exploring data mesh powered by GraphQL. So the official introduction for Tanmay is he's the CEO and co-founder of Azura. He's the Stack Overflow powered full stack developer whose areas of interest and work span React, GraphQL, Node.js, Haskell, Docker, Postgres, and Kubernetes. He's passionate about making it easy to build complex things, and is the instructor of India's largest MOOC, iMed Tech, on over 250,000 students. I also can say personally that he's one of the nicest, smartest, and funniest individuals in the GraphQL community, and I'm very proud to call him a friend. Tanmay is wondering, and in the poll question for his talk, he's asking all of you, in your GraphQL stack, which of the following is the topmost concern or biggest blocker for your teams? This is very interesting questions. The options are time spent in writing resolvers, performance, authorization and security, or you're just basically not using GraphQL right now. So let's give it up for Tanmay. You can ask questions on the Discord channel. Tanmay, the stage is yours.
Hi, folks. I'm Tanmay. I'm the co-founder, CEO at Hustle, and I'm going to talk to you a little bit about data APIs powered by GraphQL today. So, increasingly, platform teams across various organizations are setting up a data API layer to kind of deal with this problem of saying that you have so many different data sources and so many different types of clients, and you need to solve problems of performance and standardization and security to allow these clients to move quickly. We have to deal with the fact that these data, the domain data is kind of coming from different sources, databases, services. Clients can be internal or external. They can be at the edge. They can be on the cloud. They can be on-prem. They can be within the same team. They can be across different teams, right? And we need kind of a data API layer that can absorb and solve for standardizing the API or providing a certain performance quality of service or providing security compliance guarantees, right? As a data API, GraphQL can be a great fit. And we'll see some of those benefits of GraphQL in addressing some of these challenges as well. So GraphQL is a nice API because, as we all know, it allows us to select exactly the data that we need in a single API call. This has a pretty large impact if the amount of data that we're fetching is fetching models that have hundreds of attributes, where we can drastically reduce the load on the underlying data system. Increasingly, as we move to serverless vendors and serverless data vendors, there's a massive cost-saving impact that also happens when we're able to select exactly the data that we need. We all know about the fact that GraphQL has a really nice schema, and you have a typed graph that allows us to select exactly that allows us to structure the way that we're getting kind of our output, but also it allows us to structure our input and parameters very easily, right? And that has an impact in our ability to handle increasing complexity. When we think about this query here, when I'm fetching orders, I'm fetching orders where the user is greater than a particular value and it's ordered by the user ID in an ascending order, right? Providing these input parameters and arguments is much more easy with GraphQL compared to trying to do this with a REST API, for example, right? And so kind of being able to layer on this complexity becomes much easier. When we think about taking these kind of niceties of GraphQL that we're all aware of, when we think about standardizing and scaling this, we kind of run into some challenges. At its core, it's because the cost of providing this increased flexibility means that we need to do a little more work in solving for kind of standardization or schema design and guaranteeing performance and in solving for authorization and security, right? Let's take a look at performance, for example. If we think about the types of data sources that we have and the way that we execute a query across those data sources, that optimal data fetching that we do can be very contextual. If we take the simple example of fetching orders and the user for each order as well, the username, depending on kind of the topology of this data, we might have varying query plans, right? For example, if it came from the same data source that supported JSON aggregations, if I had to implement a controller that would result and respond with just this data, I could make a single query that would perform the JSON aggregation at the data source itself. And that means that I'm not even doing a join that fetches a Cartesian product. I'm making a more efficient query that is fetching just the order, the user, constructing the shape of the JSON, and then streaming that back to the client. Let's say it's coming from two different databases, in which case I would use something like an inquiry and perform memoization so that I'm not fetching duplicate entities, and do kind of this cross database join, right? If this was coming from two different services, then I'd have to make multiple API calls. But again, I would do a form of memoization to prevent duplicate entities being fetched within the same request. And it's kind of variations of the data load pattern. But the idea that this query plan depends on the kind of data that we have, and the same kind of query plan will not work across these different data sources. There's an interesting thread that popped up on Twitter a few weeks ago where we talked about some folks talked about how GraphQL doesn't create an N+1 problem. Then Nick, one of the creators of GraphQL, kind of chimed in saying that, well, GraphQL doesn't create the N+1 problem, but because of the way that we typically think about executing a GraphQL query, it does make it harder to address that problem in kind of a systematic way, right? And that's kind of what we look at and we see how we can address those kind of challenges. When we think about authorization, very common challenge is that we have to integrate predicate pushdown along with our data fetching. Again, if you look at the same query where we're fetching orders and user, and let's say this query is being made by a regional manager that can only fetch orders that are placed within the region, within their region, right? And so if we made a naive kind of request where we selected all of this data, and then after selecting the data started filtering by region, terrible, right? We obviously can't do this when you have millions of or billions of rows, right? And what you want to do is you don't want to fetch that data or select from orders, from the orders kind of model or table or whatever, right? Where the region is equal to the current region. So this is the predicate, and we're kind of pushing down that predicate in our data fetch, right? And we'd want to be able to push down our authorization logic with our data fetch as much as we possibly can. Doing this across data sources can become challenging, right? When we think about API design, and as we start kind of layering on more complicated workloads, when we think about aggregations or complex filtering or what kind of pattern we want to follow for mutations, this can also be something that we need to kind of think about and standardize. Let's take a few examples of where these challenges pop up. If you think about fetching users and their total number of orders that each user has, right, with an aggregate property that is kind of added to the user type, right? And so, how do we want to think about this, right? Do we want to add this as an attribute to the user type, which is what we would do conventionally? But what if we wanted to have certain arguments to that so that you only fetch those aggregates with a particular condition, like only orders created after a certain date? Or what if you want to layer on other aggregate properties? What if the order service is a totally different service from the user service, right? How do we want to expose aggregations from a different service being kind of quote unquote federated into a model definition that's coming from a different service altogether, right? And so we kind of need a way to think about the design here. When you think about querying a parent by a property of the child, right? It's not a property of the parent, but a property of the child. And again, in situations where this is kind of federated, this becomes a complicated thing to design. And you want to have kind of a standardized design when you think about scaling to these kinds of workloads as well. When you think about mutation, you have two broad types of mutations, right? You can do kind of this CRUD-ish style of mutations, and that's nice because you can compose well. You can say that I'm, inserting an object and a bunch of related objects together, or I'm updating them, or I'm inserting them, or deleting them, and stuff like that. Or you can think about a non-CRUD style where it's kind of more CQRS style of mutation, where you have a unique mutation for each type of action that you want to do. And although this is nice, it does make it hard to standardize, right? So we want to be able to handle both of these flavors well. So if you think about wanting to address these challenges, given that we're going to do it anyway when we think about data API, let's take a look at what benefits we would get from a kind of more rigorous technical foundation, right? So let's take a look at what would happen if we had better query planning. For this set of examples, I'm going to continue using this e-commerce-ish example where I have users and orders and a logistics service, right? So I have a user service, an order service, and a logistics service. And the user model has orders and order items. And track order is kind of like an API call that performs some business logic to interact with, say, a FedEx API or a UPX API to fetch the order status. If I look at a simple query like fetching orders and the user for that order, depending on how that data is laid out, I might have 3 different types of query plans. I might have this nice plan where I do n+1. I have a serialization, deserialization overhead. I might do batching where it's possible to batch, kind of like a data loader, where I have to make 2 IO calls at least, and then perform JSON serialization, deserialization. Or in the best case, where this kind of data is laid out in a way that I can make a single call and then perform the JSON serialization, deserialization just in one place and stream that back, right? Kind of what we talked about. When we think about the benefit of this query plan, right? And we look at what this looks like in practice, benchmarking P99s at about 1000 RPS, increasing the depth of fetching data that is coming from 2 different services. If we look at this kind of approach where we let better query planning happen and not just default to kind of a data loader style n+1, there's a massive amount of performance gain that we can get, right? You can see that the blue is where there's query planning, and the red are where I just have kind of a GraphQL gateway that is federating out to 2 different GraphQL services that is then fetching data from those underlying sources, right? The benefits kind of add up where I'm fetching just the right slice of data from the underlying database, where I'm performing minimal amount of repeated JSON serialization, deserialization, and then finally getting to the shape of data that I want to have. When we think about the benefit that we want on the authorization side, let's take an example where we have this track order API call, right? Where I'm fetching information about the delivery status or the order status for a particular order ID. Now, typically, if you wanted to have authorization logic that guaranteed that when I'm placing the order, I'm only looking at the order that I can look at as a user, the order belongs to me. What we'd have to do is we'd have to push down that authorization logic and ask the folks who've implemented the track order function to implement that authorization logic, right? So what I would do today is that in the logic or in the controller that does the track order, I would want to fetch the order information, get the user information from that, fetch the user information that is related to that order, and then check a condition about the current session and whether that is connected and how that's related to the order and that order's user. And then depending on that condition, I would then actually validate it and make an API call to the actual logistics service and do whatever business logic needs to be done to return that order status, right? This authorization logic in orange is what I would like to be able to externalize, right? Because we're kind of doing this graph traversal where we're saying if the input.order.user is current user, right? Some condition like that, I would like to evaluate that condition and then make this business logic happen. You can think about more complex scenarios where I have multiple queries and I have repeated authorization checks. It's kind of doing this data fetching thing and graph traversal thing that we saw in just vanilla data access, but we're doing that for authorization as well. And the same benefits that we want on data access, we can start to bring those benefits to the authorization layer as well. Apart from the fact, of course, that we're now able to centralize authorization and guarantee a degree of security and compliance the data API layer itself across different types of data sources. So when we kind of think about what powers this, right? One of the key ideas that powers this is the idea of predicates and aggregations that compose with graph traversal. Let's take this example of where I'm fetching, users and orders, right? And if I want to make a query that fetches an order where the user region is equal to a particular value, this is where I'm kind of bringing in a property of the child, and I'm able to bring that property of the child into the parent. And then I'm able to kind of evaluate a predicate on the child for the parent. And it's not just about kind of the syntax that we'd want on the GraphQL API side, but we'd also want our data API engine to be able to evaluate these kind of related predicates and push them down into underlying data sources wherever possible, right? This is interesting code to write, even if the data was in the same place. And it's obviously very interesting to write if you think about it as coming from two different data sources, two different services, right? And this is what we want to be able to do. All right, so how would we go about doing this? And that's going to be the second half of what I talk about today. The first problem here, or the key insight here, is that we want to make sure that the right information is available at the right layer. Conventional ways of doing GraphQL and executing a GraphQL query, it couples the execution model to the GraphQL query and the GraphQL schema structure, right? So for example, we're forced into, when you're servicing a query that fetches orders and users and stuff like that, we're making a breadth-first traversal, and we're calling these resolver functions in that kind of breadth-first way that is looking at the GraphQL query, and then we're executing the logic there, right? This, when we're forced to kind of write our logic in that particular way, then we need a data layer that can understand those things. And this is very challenging to write because a generic data layer across these data services then becomes challenging, right? Kind of think about all of the problems that we were talking about. What we want to do instead is think about decoupling the syntax and the semantics of our GraphQL API from how it's executed. We move from kind of this GraphQL server idea to a GraphQL engine, right? And the GraphQL engine uses a domain graph, not the GraphQL schema, it uses a description of the domain and description of security policies on that domain, etc., and how that's mapped to underlying data sources. It allows a certain way of composing predicate functions and aggregation functions, and it can do that query planning to fetch data from that domain graph. And then on top of that, it exposes a GraphQL schema that is derived from that domain graph. But how a particular GraphQL query is processed is left entirely to the GraphQL engine, right? Whether, for example, it's going to be making multiple API calls, or it's going to be composing or compiling into a single query, that execution is kind of left to the GraphQL engine. And we are not kind of thinking about it from this point of view of calling a graph a function, right? Another way to think about this is that it's kind of GraphQL without resolvers, right? I guess the mental model that I'm trying to go for here is saying that if you have to think of your GraphQL server as calling a graph of function, right? And executing that graph of functions when you call a GraphQL API, instead of that, what if we move to this model of saying, well, we have a graph of our domain and we're making it accessible over a GraphQL API. So we're kind of focusing more on the domain, and we're using GraphQL API as a way to access that domain rather than thinking of the GraphQL API as our domain. So let's take a look at what this kind of specification can look like. We looked at GraphQL, we looked at row-level security, we looked at graph databases, looked at relational algebra and how composition works, techniques like foreign data wrappers that systems like Postgres have that help bring different types of systems into a relational system. So kind of looking at all of this, we can describe a GraphQL data specification that is composed of three pieces. The first is domain graph description, which describes kind of models and edges, commands that are a part of that domain, right? And that come from different data sources. We then have this notion of node level security. That is an authorization language and policy framework that allows nodes of that domain graph to be validated or constrained or filtered. And then finally, we have conventions and a particular grammar to generate the GraphQL schema and API from the underlying domain graph, incorporating these node level security loops, right? So let's take a look at what the domain graph looks like. So this language is intended to describe the models, the fields, and the edges in the domain. It describes commands that can take a model as an input and return a model as an output, right? And the GraphQL engine can interpret this domain graph. It should provide predicate functions and aggregation functions, pagination functions, and stuff like that that can operate on that domain graph, right? Let's take a look at like what this looks like with our e-commerce-ish example, right? And visualize this. So if you look at kind of this models graph, right, we have these nodes that are connected together, right? And we have commands that take a graph as an input and return pieces of the graph as the output, right? This becomes the input to a GraphQL engine that is now able to evaluate predicates on these nodes, right? And can say that, hey, here's a particular expression where we want to evaluate a node, traverse the graph, and evaluate a property true or false. We want to be able to evaluate aggregations on sets of nodes, right? And the GraphQL engine should know how to select, stream, insert, delete, and update or invoke commands on that particular graph. So this is the work that the GraphQL engine should be able to do given this input. If you take a look at the specific e-commerce list example, right, we had a data source where we have a model for a user that has an ID, a name, and an edge to orders. We have orders that have ID, amount, user ID as fields, and an edge back to the user, and an edge to items, which then has the item description and stuff like that, right? We have the track order API call, where there is an input model that takes an order ID, and you see that it has an edge to the order model itself. And you see the output model here, which is the order status, which has description for status and stuff like that, but also an edge to the order model, right? You see this command that can take an input model and output model that takes an input and returns a particular output, performs some logic in the middle. So this is kind of how we'd want our domain to be kind of mapped into a graph, right? To a set of models and edges. Now, the key part of this is predicate functions, which actually makes the composition magic happen. So as soon as we have a user model, we want to generate predicate functions that can evaluate properties on the user model. So we can do and or not expressions. We can have an ID. The ID can be compared to a value with certain integer operators, string operators, region string operators. But when we see an edge to order from the user model, we're also able to traverse the order Boolean expression. And we're also able to traverse an order aggregate Boolean expression. This is what allows us to say things like, where the user dot total orders is greater than 10, right? And so you're kind of able to create or evaluate a property of the user model by composing related entities as well. And similarly, on the order side, you can do the same thing where you have Boolean expressions on those fields itself, but you're also able to compose Boolean expressions of the edges, right? And this is what allows us to have functions like user.orderaggregate.count greater than 5 or order.user.region is equal to North America or EMEA or something like that, right? And this is what allows this kind of evaluation to happen. This is what will, as you can see, will show up in our filtering or will show up in our node level security rules and stuff like that, will show up in the argument for a GraphQL API and things like that. Coming to node level security, which is the second piece of this specification, for each model, we can attach a permissions policy, right? And that policy decides what attributes of that model are accessible, and a constraint predicate that has to be met to filter this or to validate this particular node when it is accessed, right? And you can model allow and deny kind of rules as and or not operators. You can have multiple policies, and you can define how you'd want multiple policies to be composed together, right? So you can select overlapping parts of the graph, select the right pieces of data from overlapping parts of the graph, stuff like that. Again, just taking a step back to look at what this looks like on our e-commerce example, right? On the user model, we'd have a node level security rule that says if the user.id is equal to the current session user ID, I should be able to kind of access it, right? If I look at order items, I can access an item in an order if that order actually belongs to me. So if the item.order.user ID is equal to me. If you look at our track order API call, the input model can traverse the edge as well. So I can say that the input.order.user ID should be equal to the current session user ID. So I can kind of traverse inputs in the graph as well, right? And then validate that and check if certain things are, if that operation is allowed, for example, or if that data can be returned as a response of that command, right? Or as a result of executing that command. If you visualize this from a graph point of view, it kind of feels like you have this graph of models, and an NLS rule, essentially an NLS policy, allows you to create a subgraph with certain attributes and certain nodes that are accessible, right? If you take a look at a command, you're kind of saying that the input graph must be validated, that this graph is actually allowed to exist for this command. And then the output is filtered so that you have the right response set that you're able to see by executing that command, right? And that's kind of what node level security looks like. Finally, based on these two things, we have conventions to generate the GraphQL data schema and API, right? So for example, you'd have the query route, which then allows you to fetch models and their edges with the predicate functions, right? So filtering, you can fetch aggregations on lists or on related lists. So that allows you to do users and users dot order aggregate. So you can compute users, but average order amount and total number of orders and stuff like that, or the average number of items in a single order, and that can compose well into a query syntax. On mutations, if you're on the CRUD side, you can have insert, update, delete semantics for models and edges where CRUD is possible and where you want to expose that CRUD. And other places you'd have mutations for commands where you can invoke those commands, right? And that convention is what kind of generates the right GraphQL schema from the underlying convention. Now, we can kind of see that the benefit here is, on the performance side, and on our ability to compose and design the API, and of course to externalize authorization rules so that we can kind of create a standardized security and compliance layer for our data API. That is, a unified approach across different kinds of data sources. A bonus benefit, apart from being declarative and our ability to kind of reason about things at a domain graph level and look at authorization rules, is that you can also use the same technique to build an automated API cache, data API cache. Let's take an example where I have documents at teams. I have a document model, right, that has an ID and a title, and each document belongs to a team, and a team has a list of users, right? Authorization rule on document would say that if the team.users contains the current user, I'm allowed to operate or access this document, right? If user 1 was making a query to document, user 1 belongs to team 1, and if user 2, who also belongs to team 1, queries the document, we want a cache hit to happen. And this cache hit can now happen because the authorization rule is the same and can determine that user 1 and user 2 are actually going to result in a cache hit, right? This kind of logic is hard to externalize unless we externalize the authorization rule itself. So our authorization rules are also kind of becoming cache key rules. And that's what you would have done if you were kind of building this yourself. But now we have an approach to kind of scale this out and standardize this across whatever model we have, whatever edges we have to traverse. So to quickly summarize, we looked at data APIs, we looked at how we can design and standardize a GraphQL approach for data APIs. We looked at node level security as an authorization practice. We put this together at on GitHub at GraphQL data specification, and there's a playground there as well that you can check out. There's a formalism with a draft specification. It formalizes the grammar, and there's a playground where you can input certain models and edges and see what the authorization looks like and see what a GraphQL API design would look like. And you can use that if you're thinking about building a data platform or a data service or a data API inside your organization. If you're doing something like that, I'd love to hear from you. I'd love to exchange notes. But that brings me to my time, and hopefully that was an interesting introduction to how data APIs work with GraphQL. Thank you.
Wow, that was a really amazing talk. Thank you very much, Tanmay. You can join me on stage now. Happy to have you here. Thanks for joining. Thanks for your poll question. I think it was a very interesting question. Let's maybe look at the results. So if you look at the results of your question, the question was, in your GraphQL stack, which of the following is the most concern or biggest blocker for your teams? And the options were authorization and security, performance, not using GraphQL right now at all, or time spent in writing resolvers. So authorization and security was the top result. And then second is performance. I guess maybe from that, by the way, I'll just tell people that you can continue asking questions on Discord if you want, and I will ask Tanmay these questions. So thinking about your talk, how do you think, it looks like there's
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
we have very exciting things to continue the conversation with. So first of all, thanks, Tanmay. It's a pleasure as usual. It was very, very interesting. Thank you for this session. Thank you. And moving on, first of all, before moving to the next session, I just want to remind you about our raffle of the conference. There's t-shirts and multi-passes. What you need to do in order to join, you need to tweet with the photo of how you're watching the stream and then add the hashtag GraphQL Galaxy. And yeah, if hopefully the people in the cloud will choose you and you will win amazing prizes. So yeah. And now we're moving on to the next panel that we have. This is a very interesting panel. I'm very excited about this. The future of server-side. Okay, so we're going to have a panel of the future of GraphQL server-side GraphQL with really amazing participants and speakers. Before that, we're going to have a 5-minute break. But I'm looking forward for this. I will also join this. So let's take a 5-minute break. By the way, you can also, as I mentioned before, join the Discord, ask us questions, so I can also ask the distinguished panel the questions that you're coming up with. And yeah, see you in 5 minutes in the next panel.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Hi, everyone. As I said before, I'm really excited for the next panel. There's really interesting guests and speakers that are part of it. Let me invite them first so you can all see and talk with them. And while we also are speaking, you can ask us questions on Discord, on the Andromeda channel. We want to hear your questions and we want to address them all, or at least what we'll have time for. Let me introduce those distinguished guests, starting with Benji from GraphQL. Benji is a community, GraphQL is a community-funded open source project, and Benji is the main maintainer. He loves doing GraphQL, truly loves doing GraphQL and helping the community. I'm really excited to have Benji here. We have Danielle Mann from Apollo. She's a senior director of engineering at Apollo. Danielle has been working on making GraphQL easier and more delightful to use for the last 6.5 years. It's amazing to have someone with so much experience here. And Tim Shuchanek, I'm sorry if I'm butchering your name, from Stellate. He's the co-founder and CTO of Stellate. Tim was the first employee at the first GraphQL backend as a service tool that we all remember 6.5 years ago, and is now working on making it easy to run GraphQL APIs in production at Stellate. And Frederick Bjork from GraphBase. He's the founder and the CEO of GraphBase. They make it super easy to deploy serverless GraphQL backends. So thanks everyone for joining me and for this panel. And this panel has a very big title. What is the future of GraphQL? And I think there's all of us probably have a lot of different perspectives from all of the many different areas that the people here are part of. So maybe we can start with Benji, just in a very, let's call it general terms. How do you see the current trends in GraphQL? Like when we started and where we are today, and some of the exciting things you are seeing out there?
Thanks, Yuri. GraphQL, I think, has grown quite impressively. It sort of rocketed out since its launch in 2015. And it's really interesting to see people. I think the base GraphQL addressed a lot of people's problems, and we're now starting to see the edge cases of those where certain patterns aren't fully covered, and we're then looking to deal with those. So in my work with the working group, we've been receiving the requests and the ideas of various people as to how to advance GraphQL, how to make it serve all these different needs. And I think Lee spoke about earlier the new deferrent stream, which is one of the exciting things that is being added to GraphQL currently, which is great. But there is also a huge number of other proposals that are all being worked on as ways to advance GraphQL. And some of them may never see the actual final release into the spec. Some of them may spawn better ideas that solve the problems in better ways. But what I love to see is people really getting involved and working together to find these solutions to these common problems. And rather than thinking, how can I solve this for my one business, thinking, how can I solve this for everyone that uses GraphQL so that this rising tide can lift all boats, as it were.
Yeah, and I see, I'm really interested also in Danielle's perspective, because I know that in Apollo, you're basically probably seeing so much of user stories and how many different types of companies are using GraphQL, both on the front end as consumers and back end. How do you approach this question?
Yeah, I think as the last 6.5 years have progressed, we've really seen GraphQL kind of move from being a super early technology that needed just a lot of basic tools to help you use it in general, to now we're kind of entering more of the early majority phase, where a lot of people are looking for more sophisticated things out of GraphQL and starting to build off of GraphQL to do things like defer, or to do things like live queries, which is something that we talk about at Apollo. So even just for the use case of defer, I'm really excited about how we're starting to get to being able to roll that out, because with defer, it doesn't just make your GraphQL queries more performant. Well, it does, but it's not just about making your queries more performant. It actually, once you've moved that kind of consideration of how the data will load in chunks back to the GraphQL query layer and out of your React render layer, you can make your React apps a lot simpler. You're going to architect components in a different way, because you're no longer going to need to break up front-end pages component by component just because you need to load data progressively. So even just within the last month, I've started to play around with defer in some of my own apps, because we had an early implementation at Apollo, and I was realizing some of those things, and I was having this moment of oh my gosh, this is going to change how people build their front-end components. This is wild. I'm excited about GraphQL all over again. And so I'm really excited that we're entering this phase of defer, live queries, all these other caching, what Tim is doing, all these other amazing things on top of GraphQL, now that we've gotten past the basics of just making GraphQL available to the masses.
What do you think would be the biggest conceptual thing that people can now do with defer? The biggest aha moment for you when you started playing with this?
So my aha moment, we have a big front-end app at Apollo called Studio, and every time we load a list of things, have one query for the list and then one query for every component of the list, so that the list can show up, but then metadata on that list can load more progressively. And so when you just load one page, it's maybe 100 queries, which is just so many. And so I had this aha moment of oh my gosh, with defer, this no longer needs to be organized this way. This can all just be one query. It's going to be so much better for the front-end developers who no longer have to break this component up on these boundaries. It's going to be so much better for the server that no longer has to deal with mega load. So even just that, it was such a simple moment, but I was the potential here is so exciting.
Yeah, I agree. And you also mentioned live queries, and I know a bit that GraphBase has started playing a bit with those things. Maybe you can take the question from your perspective, Frederick. What are the most exciting upcoming things for you?
Absolutely. I think just to double click on GraphQL where we are, I think the fact that it's becoming a bit boring is a good thing, right? It's no longer being hotly debated. It's here. And it's here to stay. So I'm pretty excited about that. Now we're refining and adding things to make it easy for anyone to adopt and to generalize common patterns. So I like that. But yeah, on our end, we're also looking at defer and stream, and we actually have experimental support for live queries already. And most people I think know of GraphQL subscriptions, but I don't know, not everyone knows about live queries. So that's another example of just making real time really easy. And that's obviously something that we care deeply about, because we want to make GraphQL servers easier. I think the kind of common knowledge, at least in my experience, has been like building GraphQL servers is a bit hard and fragmented. So that's something we're excited to make better.
Yeah, I mean, that leads me to the next question. Like, I think, I agree with you that like we got to it's funny how you said it, like we got to the boring phase where, we know more or less what is GraphQL, like we have these things, but now there's some challenges. And I think probably someone who's like, been into this problem for so many years is Tim, like, because of GraphQL, right? Like, where you're one of the first that actually looked at like how to make it as easy as possible, as simple as possible. And you've been through a lot, of waves and like iterations over these 6.5 years. Like, where do you see I guess, let's say the current challenges, like of where we are in, and what would be the easiest wins moving forward for the community?
Yeah, so I think that's actually a good question, and I definitely have thoughts on that. I think that there are two, let's say, big areas. I see education and tooling. And I would even say that education is probably more important right now, because we see that there are a lot of misunderstandings. Every second day there's a discussion these days. It's a bad tool or whatever. And you see that there's just a base misunderstanding. I think it starts with, we see that GraphQL is very valuable in teams and companies. You have GraphQL as a collaboration tool. It brings people to the table, at the same table, and they can talk about something. And now it's kind of a forcing function, has a lot of advantages there. And I think that's still something that many companies don't understand. And for that, you first need to understand your own. You first need to be introspective in the company, understand your own issues. Let's say there are 10 different authorization solutions out there. What is the issue? It's maybe a governance issue. Okay, once you identify it, now you can see, is there maybe a tool that can help us? And I think that's like a few steps down the road, and it's a lot of education that needs to happen to really get like the benefits. Like also relay style GraphQL is also still quite different than what is used in, let's say, in a lot of, let's say, starter projects, and people have like this barrier to relay, although there are a lot of advantages in it, and I think there's a lot of education needed. On the tooling side, I think everyone here is like working on something to make it easier and move GraphQL forward, and it's a huge like it's like something on all of us, right? Not just one person or company can move that forward. And I think as long as we all move forward, and that's like the spec is combining all of this, is holding us together, I think that's amazing.
Yeah, I think I agree. I think education is very important, and also, but I always keep wondering if we can. There's education also sometimes means people need to know more things, or to, some things are just make sense when you're getting into more complex applications. But I always ask myself, can we build better tools for the beginner, where you start easy, you get what you want, and then you just gradually you gradually get into where you want without I don't know, jumping between things. Or I wonder if any of you have I don't know who wants to take it, like but how do you imagine us solving this path in the future? Like, let's say I'm a beginner, I'm starting, I don't know if a beginner, but I'm a developer who's starting a new app, and I want to start easy and fast, but then I want to make sure that I'm not cornering myself to things. Do you think we're there right now? Do you think there's things needs to be changed? Do you have concrete ideas of things like that? I don't know, maybe Danielle, you can take it.
Yeah, I kind of wanted to ask the rest of the panelists, because my take on that is we have so much material on helping complete newcomers to GraphQL get started with GraphQL. Like, we have starter kits, we have a lot of easy ramps, but I feel like what we're still in the process of building in this community is easy answers, easy standards for the more complicated and advanced questions. Like on the Apollo side, we have a lot of tutorials. We have our Odyssey learning courses. We have like a lot of docs with getting started guides for, yes, how do you write a resolver? Yes, like how do you write a query in your client app? But once you start getting to more advanced, complicated topics, a lot of that is still very much within specific companies, specific technical teams. And I feel like we haven't standardized those answers. And Benji, I was actually kind of curious from your perspective how you think about that, because right before we hopped on the panel, Benji and I were talking about his new project around a different way to write GraphQL resolvers. So I'm curious how you think about teaching people how to do GraphQL well on the back end.
Yeah, it's a great question. And I think one of the key things to keep in mind with GraphQL is it was always built to solve client problems. It was always built to solve the problems of the front end. And just like you were describing earlier, Danielle, with Defer and your breakthrough moment, it's always focused on making those front ends easier. But like Frederick said before, it's not always the best at making the back ends easier. And there are so many different approaches to building GraphQL schemas. I mean, even choosing what programming language you're going to build them in is one first question. And then even from there, you've got various different questions depending on what libraries you have available. Do you want to go schema first? Do you want to go code first? Do you want to go database first? Do you want auto generation? Do you want to do it manually? There's even fundamental questions about the design of your schema, like should you be using cursor connections, or do you just want simple lists? And I think a lot of people always want to start the simple way. But one of the things that GraphQL tries to help you accomplish is making your schema backwards compatible, right? You want to always be able to add stuff to your schema without breaking previous applications. And so there's quite a few patterns in GraphQL that initially seem overcomplicated. So connections, for example, the mutation pattern where you have like an input object and a payload object, and various things like that people might initially think, oh, I don't need all this stuff. You know, I just need to, if I'm going to create a post, I just need to return the post. But then later when they realize, oh, actually, when I create the post, I also want to know, you know, maybe it costs me some money to create the post. How many credits do I have left after this? If you had done it with a payload, then there would be this space afterwards. So it's always about thinking in terms of the future of your schema. And I think that is maybe where education on the front end of how to consume GraphQL is relatively straightforward, because you've already got a schema. Someone's already designed that for you. Now all you need to know is, how do I query it? How do I integrate this with React or Vue or Angular, whatever it is that you're working with? Whereas on the back end, it's not just a case of learning what GraphQL can do, but it's also learning what it should do and how that integrates with your business domain. And I think that's quite a hard challenge to solve in general. You asked about my project, which is called GraphAsked. And one of the things that I see a lot of people saying about in GraphQL is you know, the N+1 problem and the caching problem and various things like this. What GraphAsked sets out to do is to solve these problems out of the box by actually getting rid of the resolver-based execution model that we have in GraphQL currently and replacing it with a completely alternative execution model. Now, this isn't to say that resolvers are concretely bad or anything like that. It's more to say resolvers set like the baseline of here is what it should look like, here's what it should be perceived as to the user, as if it did this. But on the back end, if we do something a bit more advanced, but not necessarily with more complicated code, we can achieve better outcomes, and we can sidestep a whole number of these problems, the N+1 problem and much more, just out of the box.
What are other interesting like ideas that makes it easier to solve to build GraphQL servers on the backend? Like, do you see other interesting ideas? Like, by the way, I saw a glimpse of GraphFast. Is very exciting, And but I know that other, like both team and both teams and Frederick have also interesting ideas there. Frederick, maybe do you want to also give an idea of how you see like this idea that writing GraphQL on the backend is hard?
Oh, it was muted, sorry. I was going to continue on what Benji said there in terms of, there's just a lot of decision making you have to go through before you actually see the API on a URL in production somewhere. And I think that's the problem we want to solve. So we want to have really low barrier of entry, starting with your terminal and local dev, right? I don't want you to have to install Docker or Java or set up complicated YAML files or anything like that. I want to get you from the idea to the URL, and it's short. That's the kind of benchmark we need to look for. It should be minutes, not like a day or two, right? So I think that's an interesting proposal, and I think we're starting with the simplest thing in my mind, which is one file and it's schema first. But of course, like I see the benefits of having code first when you reach a certain scale, so we will definitely allow that. But what is the simplest way to get a front-end developer to deploy a GraphQL API? That's really what we're looking for now. And over time, making it more interesting for full stack and back-end devs to deploy GraphQL servers. And I think, like, if I would put an analogy where we are now, it feels like we're where React was before there was a framework and another framework. So a framework for React, I feel we need more frameworks for GraphQL that make it really easy to adopt. And I'm not going to use any names, but I think you know the names. And they're really successful and I like them. But now we're also seeing that go into another phase. But I think that's what I'm looking forward to, seeing the coming generation of frameworks.
I guess so. When it's interesting your idea of frameworks, because I mean we are talking here about backend and front end, but also in GraphQL it's kind of like made the boundaries a bit more weird. Like there's a lot of front end developers that started writing schemas and resolvers and backend code, and suddenly the boundaries became less expressive. Like who are we talking about now that when we're writing the backend? And like I think one of the things that I liked about GraphQL is that for me personally, even it opened the doors to learn about all these concerns that Benji was mentioning. Like before that, I didn't even think about it, but with GraphQL, I kind of like gradually got into that. Like I started with just writing GraphQL, and then I had to solve this and I had to solve that, and I got tackled into this and got tackled into that. So I guess there's also a question of maybe it's less backend and front end, but more let's call it data source implementation, GraphQL APIs, front end consuming. Like there's many different boundaries there, and the roles are also like different, I guess. Like I think also for me, I mean, I wanted to there's the complexity on the backend that we mentioned. I think there's for me also this question on the front end. Like I think for us or for the people here looking at a GraphQL query seems like the most simple and beautiful thing, and just like a very nice abstraction. But I think what we see from the community in the last few months, at least, is that maybe for some people it's not the most it's not the best. Like we see more and more people that are let's call it front-end developers or product developers that are telling us things like maybe GraphQL is not easy enough for us, maybe we want something simpler for some cases. Like there's let's call it the elephant in the room, but TRPC, for example, or all kinds of alternatives. And I wonder, I have a very particular opinion about it, but I wonder if any of you wants to, what is your opinion of this kind of trend or this kind of, let's call it sentiment right now, where people are saying that GraphQL on the front end is harder than it should be? Tim, maybe you can take it.
And go next, yeah. I mean, I have been building the Prisma client, which is basically a type-safe access to your databases. It's not an ORM, it's a query builder. And actually, the implementation under the hood, it looks quite similar to GraphQL. So it's possible to build something that is nice and easy to consume from TypeScript. You have a little bit of syntax overhead always. I think the minimum, absolute minimum beautiful syntax is still GraphQL. You probably can't reduce it. However, something I think that is beautiful in TRPC is that you have global type inference coming without me having to provide the output object type. I can directly just use it in the front end, and whatever I'm returning, I'm done with it. And I mean, in a sense, that's the trade-off you make with GraphQL that you also have with REST, right? Recently talked to someone who's using REST in a company that just grew from 40 to 400 people. And they have the mantra, if we need an endpoint, we just build it. And you can scale quite far with that. And I think what's nice about it is that every endpoint, REST endpoint, is kind of an isolated container almost. That thing only does what it does, and you can control it. Of course, it's not really scalable. And there's a reason that many big companies came to the same conclusion that the direction of GraphQL to Falcon and so on all moved in that direction. So I think at a certain scale, it makes sense. I also think that there is for sure a point to make on making some default selections maybe into building that into the clients. That's a design decision we made back in the days with Prisma Client, that we say scalars are, for example, the default selection. In many cases, if you say user find many and the server and the database are next to each other, it's fine. And I think that's also something you see in many GraphQL server implementations. It's probably not something that will ever happen in I guess in GraphVast. That's what it's for, right? To have really the super optimized query plan. But yeah, I think maybe looking into default selections, that could be a direction as well. And I'm personally a big fan of TypeScript bindings. And also I want to mention that, I mean, Flow still exists, right? I mean, it's all about TypeScript these days, right? And Flow exists. And I mean, not too long ago, they added more GraphQL language support directly into the language. And that might also be an opportunity with TypeScript. I mean, GraphQL by now is not just a little niche language anymore. We could also see is there something we can do.
That's very interesting. I think, yeah, there's always the question, like when, also on the front end and also on the back end, but in the front end of when should you start introducing GraphQL? And I think, yeah, like you said, the TypeScript integration today is, I think, something that many people are mentioning is painful. They look at the codegen step as something that is painful for them, and they want like inference. But personally, we tried all kinds of things. Currently, there's some lacking features in TypeScript actually that makes it a bit harder, but might be interesting to tackle it as a community maybe. To make it so you won't need a codegen step on the front end. Also, I guess some of you mentioned frameworks, and I wonder, if we're looking at the use case of, let's say, specifically TypeScript on the back end and on the front end, like, could we simplify some of these steps if we assume take all kinds of assumptions, right? GraphQL is very strong when we have, we have a complete separation, and that gives us complete freedom between how we build the backend and how we build the front end, and we can use any tools, anything. But what if we do take these assumptions? What if we look at a specific audience and say, you know what, like maybe let's say you assume using TypeScript full stack. What would an experience like that look like? I wonder if any of you have thought about this, even if you are, I don't know, have any thoughts on that? Danielle?
Yeah, I could take that one, or at least a first shot at that one. I feel like there are so many tools for GraphQL. If you use them all together, you can get an experience that's kind of similar to TRPC. So that's one of the things that I love about GraphQL, but you do need to know, oh, I need to install this extension, I need to configure TypeScript codegen that way. And like even codegen, I mean, as we build new features like defer, we're going to need to move that support over in codegen, and it's a lot of steps. So I would love to see us find ways to move the underlying technologies forward. So maybe we can combine and simplify, and that stuff can get easier over time. Uri, to your question about frameworks, that's a really interesting one, because Apollo's kind of history before we were doing Apollo was with the Meteor framework, which was a very opinionated stack. And I feel like a lot of our opinions from Apollo have evolved out of wanting to provide more modularization. Meteor was like complete batteries included, full. Uri's laughing because he also worked on Meteor with us, but like full client to server integration. It was very beautiful. And also the feedback we got at the time is a bit ahead of our time, and people wanted more database options and more server options. And I feel like that's always going to remain true. People are going to want to be able to do code first schemas. They're going to want to be able to do schema first schemas. They're going to want to choose the language that's right for them, because they have a bunch of Java developers or a bunch of JavaScript developers or a bunch of Python developers on their team. So at least our current take at Apollo is embrace that, like embrace the beauty of all the different servers and try to put as much as we can in our router. Obviously, that means people need to run our router. But that's kind of where we've tried to create that batteries included experience between our router and our client, but then provide the flexibility for the kind of behind the router. People can implement GraphQL however they want.
Oh, I think, Frederick, you're muted.
Oh, am I?
Yeah, now we can hear you.
Okay.
Yeah,
cool.
now we can hear you.
Yeah, I mean, I think TRPC is a really interesting project, but I think, I think it's a novel idea to say that you're going to stay to single client, single stack. But what happens when you don't? It's like, okay, we need an iOS app, or we need a Flutter app, and then what? It's like, okay, it's a pretty hard thing to do, and then now we have to maintain two. And we need to create another REST API or a GraphQL in addition to it, and that defeats the purpose. And I think the reason we picked GraphQL is to be able to support, any language, right? Like, let's say you want to you're a Swift developer, you want to write your resolvers in Swift and compile them to WebAssembly, you can. Like, that's the kind of power of GraphQL, that it is agnostic. There is no SDK. That's really powerful, I think.
Yeah, it's interesting because, I mean, Daniel mentioned Meteor. I guess, yeah, I just, there's always this, I think once you've worked with Meteor, it's stuck, and you can't, there's something emotional that you can't let go of, like this, this full thing that it just works and it's so easy. And I think all of us have this, like, because at the end of the day, Tim, you worked on GraphQL, and Fredrik, you're now, building GraphBase, and kind of like PostGraphQL is also something interesting in that, right? Where you assume your database and then you build on top of it. So there's always this, what if I take assumptions and make it super easy, and I start very easy, but then as it gets complex, I can still gradually, get into the complexity. I guess this is a kind of like the dream that I guess everyone is just from all kinds of different ways trying to tackle this problem. And I think it's great also that everyone is trying to, because that means there's all kinds. I think just in this panel, there's like so many different solutions for the same problem, which is really, really exciting. And yeah, I think one thing I wanted to mention again was, we mentioned TRPC and front-end stuff. And one subject that I was very interested in, like, Fredrik, you mentioned live queries. And I think I also saw in Apollo's conference that you mentioned live queries. And I think it's interesting because for me, something that TRPC maybe would never be able to do is co-location of queries next to components. And I think, which I think is a very powerful concept. And for me, that was the aha moment of GraphQL, like that I can put like my data requirements next to my UI components. But then came the complexity of client-side caching and the normalized cache, which everyone has certain problems with. But if I think of like the simplest, most, and I'm going maybe again to the Meteor days, but if I would take those fragments and I will just put them as live queries, and I wouldn't care about the, like, which will be very wasteful, but I wouldn't care necessarily. I wouldn't care necessarily, you know, about being very, very optimized. Then I think maybe that could be theoretically like a very easy and powerful first experience of using GraphQL, because I can maybe, you know, write a React or Svelte component. I can attach a fragment next to it, and it will just be updated. Like the data will just be updated there, and then with time I can optimize, maybe get a more complex client, put normalized caching and stuff like that. Yeah, I don't know. This is just a random idea that made me think of things. I don't know if any of you have any opinion on that, or maybe other crazy ideas that you think could simplify or could be like a step change for making a GraphQL experience even easier than what it is today.
So I think there's quite a lot of innovation still going on in the GraphQL ecosystem. And one of the cool things that I've seen experimented with is this idea of just pulling the data requirements straight out of your component, so you don't even need to write the GraphQL queries themselves. That does look quite cool. It's challenging to do right, but it's an interesting approach. And I think we mentioned earlier that there's like the relay way of doing GraphQL, and then there's like all of the other ways of doing GraphQL. And I think that the rest of us who aren't using Relay, we're maybe not spending enough time actually pulling in some of the really good models from Relay. One of the things that I see time and time again is people just not using fragments enough. And fragments is like a fundamental building block of GraphQL, right? Like there's four main keywords: query, mutation, subscription, and fragment. And we're not really using that fragment one nearly enough. So I'd like to see that used more. And this like co-locating of the data requirements next to the components works really nicely. And having that work in the kind of defer that Danielle was talking about earlier, and having that cascade up the tree, but without delaying the rendering, and having ways of that being extracted out of just the code that you want to write, that you maybe autocomplete with TypeScript against the shape of your schema rather than the shape of your query, could be really, really interesting. Challenging, but very interesting.
That absolutely made me think. So that makes me think it's like CSS and JS, but like GraphQL and JS. I was so happy with CSS before CSS and JS that I was a little bit resistant at first when that became a trend. But then what I realized when I started using it was that it is so much faster, because it removes your kind of need to kind of create a shadow DOM in your CSS and just put it in your HTML. And I absolutely fell in love. And actually, like going back to that moment I was sharing earlier about when I realized, oh, with defer, I don't need to think about how my queries are going to load in my components anymore when I'm architecting my component structure, because this takes that away. And now I can just think about my UI again, and I can move my data concerns back to my data layer. Like, and then combining that with the GraphQL and JS, CSS and JS idea, like I think that's very beautiful. I think a UI should be able to focus on what it's trying to render, and the data loading concerns, like how fast is this going to be able to load? How do I get the first thing on the page as quickly as possible? You can move that to the data layer with GraphQL, even though it's all kind of intermingled right now. That's a very beautiful future, that you wouldn't have to think about the queries and like scaffolding out your queries and having your React components follow the same scaffolding, because they're kind of intermingled. I actually hadn't seen that, but that's very exciting.
Yeah, that's I agree. There's one library I think that kind of tries to do that. That's GQ-less. And I think it moved a lot of iterations. Like now there's the latest one is GQ-TY. It's interesting. I think those are very exciting new ideas. I think, if you break down this, currently I think it's a full client, but if, you take this idea of separate the client from the query building, and how you build the query, right? Like you have let's say the caching layer, the network layer is completely separate. And then how you build your queries, it could be, static queries, it could be code written, like there's all kinds of libraries like GraphQL Zeus and, libraries like that are code first, that are also very exciting, but also maybe something that is like completely magical, like, Danielle and Benji said, and maybe something like GQ-TY, kind of like, I agree. It's kind of like, it's magical. Like you just write your React component. You don't care necessarily where the data comes from, which was also similar to, an idea from Apollo Client, where you basically wrote a query and some of the data of the query comes from, client-side resolvers or client-side cache, and some of it came from remote, and you didn't care. Basically, you could just write your query. If we will have all of this as like an integrated thing, I think it could be very magical and could lower a lot of barriers, for many people. It's very
Which is
interesting.
basically, by the way, that's also the Rails experience. If you look into the landing page of Rails and you just check out the latest block example, also the one, the famous demo 15 years ago, basically have your templating language and you can just access the data and render it. It's just injected somehow by the environment and just there, and you can build your app. And I think there's still a good reason to use Rails these days, and some companies are able to scale that a lot. Look at Shopify. And it seems like we haven't gotten to the Rails experience yet in GraphQL. There's some attempts to that, but it also, you can't just force Rails again. It needs to fit into the new world. I'm also curious to see where the ecosystem is headed there.
I guess actually, like in Prisma, when you build the Prisma client, probably you can kind of come up with similar. Theoretically, you can come up with similar ideas. I mean, I wonder. People actually asked there was one question on the Discord channel. People were asking, how do you see the development, like React server components, impact the future of GraphQL? I have some opinions about it, but I think it's very much related to what we're talking about right now. Is any of you have an opinion or want to tackle this question?
Many opinions, but I also don't just want to speak here. I mean, first of all, first question is, does or will React Server components be the primary way to consume data in React? If you look at the Next.js docs, they say yes. I know many people who say no. So that's the first question, right? So that's something to be figured out, especially also with mobile, etc. And then within React Server components, I personally don't see a big reason why you wouldn't use GraphQL. You still want like a unified data layer. If that thing, where the code runs after all, I don't think really matters, but it's just my opinion. Yeah. What I would rather say is that maybe for React Server components, if I want to start out with the project and I don't want a lot of overhead, then maybe that's a better approach than TRPC. I don't know what you think about it. If it's just about having something quick and easy, but all the benefits where, like, again, GraphQL, team collaboration and scaling things, I would still probably use it. And yeah.
Yeah, I think for me, like even when you do, like, it's kind of like, for me conceptually, React Server components are kind of like a step in the way of people into the GraphQL world. Like it's kind of like before that, because it starts to introduce people to the idea that there's no just one route and then you fetch all the data for this one page. but you start to think actually about data and components and rendering on a more granular level. And when like the first lecture of GraphQL that I ever seen, and that when GraphQL was introduced together with the idea of co-location of queries, like of basically tied together components and GraphQL. And so for me, maybe it's just, my hope is this is maybe a step, like you mentioned education, like maybe that's one, it's kind of like a, you know, the initial exercise for people to learn about co-location of queries, which, you know, we talked about education, and I think both in the GraphQL.org and in many tutorials that I see out there, we talk a lot about how to construct the GraphQL query and how that query can then go and call many different sources. But I don't see too many tutorials out there talking about the benefit of, like you said, fragments and query collocation, which I think this is the benefit that I don't see other technologies doing, like GraphQL. I think that's the unique edge that GraphQL might have. We don't have a lot of time left. I wonder if any of you wants to maybe give a one sentence of what do you hope for the future of GraphQL for the next couple of months. We'll start with Danielle and go around the room.
I'm looking forward to landing defer, landing stream, and building more things into the language like that. I'm glad that we're finally at that point.
Frederick?
I'm looking forward to going public beta with GraphBase.
Great. Benji?
Faster execution, faster development.
Steve?
Enabling more companies and more people to access data.
And I'll finish with just having more conversations with many of the great people that tackle these GraphQL issues from all around different parts of the ecosystem, like everyone here. So thank you so much for this conversation. It was very, very interesting for me. I'm very privileged to be talking to all of you here. And yeah, everyone, if you want to keep asking questions and keep the conversation, we have a Discord channel, and you can keep on asking them more questions there. Thank you everyone for joining me here in the panel. And I'll hand it over to you, Cecilia. Thank you.
Awesome. Thank you so much. That was super, super interesting. Thank you so much, everyone, for participating. So I just want to give a reminder that we will have some amazing workshops during the next week. They're available for full ticket holders, but you do need to register to participate. First one is going to be on December 9th, hands-on with SwiftUI, GraphQL, and Neo4j or a DB with William Lyon. We also have building GraphQL backends with SDL on December 12th with Jamie Barton. And we also have, last but not least, GraphQL Mesh, the graph of everything, federated architecture for any API service protocol on December 12th as well with Uri. So make sure that you register for those. They are available for full conference ticket holders. All right, so coming up next, we have our lightning talks. This is super exciting. We actually have 4 amazing talks. So I hope you're all ready for this. You could please join me in welcoming, we have Scott Durlach, Jamie Barton, Sabine Adams, and Niels Hartman. So welcome them with a huge round of applause, and then we will let the talks begin.
What's up, GraphQL Galaxy? I'm Scott Gerlach, CSO and co-founder at StackHawk. Thanks for taking time to check out StackHawk, and I hope you're learning a ton of new things at GraphQL Galaxy 2022. Hopefully I can teach you one more. At StackHawk, we do application security testing, specifically Dynamic Application Security Testing, or DAST. Let's talk about the benefits of DAST. DAST can help you prioritize your time on what to fix in application security issues because it helps identify what's discoverable and likely exploitable, because it's testing the running GraphQL API. This is the superpower of Dast. Where should I focus my time fixing API security issues? You might be thinking to yourself, but frameworks have basically prevented any of the common AppSec problems from happening. And yes, many frameworks have done a good job preventing issues like SQL injection and cross-site scripting. Almost all of them have an unsafe version of all of those protection mechanisms to help you do complicated things and unfortunately make mistakes. Not to mention things like tenancy filtering and function authorization can be hard to get right. Some people don't know about Dast, and those that do may have run into problems with Dast. Let's look at an example. So here we are back in the good old days of legacy Dast, and when we built server-side applications that ran the data and presentation layers, everything was fine and dandy. The legacy Dast scanner could scan and test the legacy application without many problems. You get good results and identify some serious AppSec bugs. And then something changed. Then we started building JavaScript frontends. And the JavaScript frontend really trolled that legacy Dast scanner. When I say trolled the legacy Dast scanner, I meant really troll it. Like, when does the page scroll end? It never does. Where are all the forms? Well, it hasn't rendered yet because your mouse isn't in this exact pixel. Legacy Dast was running along its happy way, totally assuming it was getting all the info it needed to test these new applications. Results were terrible, scans took forever, false positive for days, etc. And the worst part is, it never realized that there was someone else in that backseat as well. Our backing APIs are in there controlling all the data, talking to data store backends, helping to render elements on the page, and the legacy Dast scanner thinks the front end is passing all these requests to the back end. Do we end up even testing the API here? Are we covering all of it? Are we even making simple requests to the API at all? Well, because of JavaScript frontends, it sort of depends. It depends on the browser and the browser emulator that the legacy Dast tool is using and how well it's driving that browser. You can think of this like Selenium scripts, but instead of a specific set of functions, you're executing it to find all the possible user input paths by itself and hoping it's going to do a really good job. Even Google doesn't do this well. So how can we get back to better application security, API security testing, better results, faster, more accurate scans, better coverage, especially around this data layer where all the assets that we're protecting are being stored? By driving this API directly, using industry standards like GraphQL introspection, you can have direct access to the API, understand what it does and the data it's controlling to get fast, thorough, accurate API security testing results. Not to mention now you can test microservices as you're building them and find these application API security bugs before they ever get shipped to production. There's still good stuff to find by testing their front end, cookie settings, DOM XSS, lots of different headers, but starting where the data is held is a better idea. What are some of the keys to look for in dynamic AppSec testing tool that will help you test APIs directly? This is where StackHawk comes in. StackHawk runs active security tests against your running API to ensure your application is handling user input and output in a safe manner, as well as implementing OWASP Top 10 API best practices for API security. We do this against your running application on your local host in CI/CD and against applications that have yet to be published on the internet. We also made dynamic testing fast by placing the scanner as close to the application as possible and using open standards to inform the scanner like GraphQL introspection queries. Not only do we make run anywhere testing possible, we've also enabled real data in testing. So providing real data to drive the API, whether that's made up with Faker libraries or provided directly through the configuration. Using real data is important to be able to test accurately GraphQL APIs. Running custom tests is no problem for StackHawk. Testing for things like broken access control or insecure direct object access, those are some of the top 2 OWASP API security issues. And you can write custom tests with StackHawk. Again, build to test modern applications, including GraphQL. Using GraphQL interfaces, presenting data in a GraphQL format makes testing GraphQL, reproducing failure scenarios, and fixing API security issues with StackHawk very easy. Our focus as a company is to help developers find and most importantly fix security issues. The StackHawk scanner and the platform were built around this simplicity model. When StackHawk finds an API security issue in your application, the platform is trying to give you the simplest version of the information needed to help you quickly understand what this problem is with simple descriptions and examples of patterns to help identify the anti-pattern, be able to recreate issues with simple tools like curl to replay the attack, get into debug and stepping through code as fast as possible to help you fix issues and get back to your regular job of creating value for your customers. All of this is CI/CD enabled. Again, you can integrate this into your CI process and importantly, get feedback in the CI process on scan findings. This information can be used to break a build if you choose, based on the severity of untriaged findings. Most of the major CI players' logos are on this slide. As long as you can run Docker or a Java process in your CI system, you can run StackHawk. And here's maybe the most important part. You can run these same AppSec tests locally. If you're developing an API on your local machine, you can test for API security issues while you're writing code. You can identify the problem, fix it, and validate that you've fixed it before you push your code back into CI/CD pipeline. Hey, I hope you enjoyed my talk today and perhaps you learned something new about how StackHawk can be integrated into your GraphQL API development process. If you'd like to check out StackHawk and see how it can integrate into your development process to keep pushing the limits on software development quality, come check us out at stackhawk.com. Thanks for watching and enjoy GraphQL Galaxy 2022.
Hi, I'm Jamie, developer advocate at GraphBase. In this short presentation, we are going to have a look at how you can add a GraphQL backend to your front-end application. We'll be using a service called GraphBase throughout this video. It allows you to go from schema to API in only a few short steps. Using the schema-first approach, you can build and deploy a backend only by writing your GraphQL SDL. Connect this to GitHub and GraphBase takes care of the rest. There's so many different features that I encourage you to go and check out, but in this video we'll explore some of them. And at the end, we'll use a user management platform to authorize requests to our GraphBase backend. There are many other things that we're working on at GraphBase, and we'll soon allow you to bring in other data sources to work with your backend. So let's dive on in. Here I have a Next.js application. I'm going to use the npx command to initialize a new GraphBase project in the root of my Next.js project. So this shows how you can add GraphBase as a backend to your existing project. Here we can define all of our models using GraphQL SDL. We use the custom directive model to tell GraphBase to generate an API for us, and then we can use the scalar types and other directives such as unique here, and in this case, for the URL of a post, we can use an opt-in to further validation with the URL scalar. We can then go on to add relations between our models, and then we can run the npx GraphBase dev command to run a local GraphBase API on localhost 4000. If we open this up and we have a look at the schema and the documentation, we can see all of this was automatically generated for us from the GraphBase CLI. And all of this works locally, and it gives you an API to create, update, delete, and read data. So in the case here, we are creating a new post. We can provide a custom URL and we can get that data back. If we try to create this again, we can see here that the URL directive and the @unique directive have kicked in. We're not able to create a duplicate post with that same URL because we said it was unique. Now let's go on to create another post, and this time we'll create an inline comment as a relation when we create a new post. So here we'll give it some text and we'll submit that mutation. Next, let's create a new comment, but this time we'll take the ID from an existing post and we'll now link this comment when we create it. Now let's have a look at fetching all of our posts using the collection query. We can opt into using the pagination, and for each of our nodes, we can get the fields that we like. We can take this a step further by fetching the related comments of a post, which also supports pagination. Finally, we can retrieve singular records for our data in our backend by using the ID or any unique field. Let's take the ID of one of our posts, and we'll now use the mutation to update. We can update using the ID or again using that unique field. And here we can provide a new title value for this post. Now if we update our query when fetching all of our posts and we get the ID of a comment, we can now use the mutation that's generated automatically to delete one of our comments. So we can provide either the comment ID, or if we had any unique fields, we could provide that inside of the arguments. Next, let's create a GitHub repository and push all of our code to GitHub. Once we've deployed the code to GitHub, we can then sign into GraphBase using our GitHub account. Then we can search for our repository and we can connect and create a new project on GraphBase. And this wouldn't be a SaaS app if there wasn't confetti. We can then explore the dashboard inside of GraphBase to explore the current schema and the playground where we can create and update data that's happening at the edge. Now let's imagine we want to add the ability for users to vote on certain posts. Well, I could update the UI and the backend at the same time in a branch. Then I can commit all of this code to GitHub and open a pull request, and automatically GraphBase will deploy a unique preview environment for that specific branch. So here I can work with data that's scoped only to that branch, so I'm not affecting anything that is in production, and I can safely work and show all of my colleagues to make sure that the voting functionality works as we expect. So here we can see we are querying and mutating some data inside of our backend that's in that isolated branch. Then, once the team's happy, all we need to do is merge and approve that pull request, and GraphBase will take care of deploying this to the edge. GraphBase also comes packed with many other features, things including authentication, authorization, permissions, and custom directives for trailing any updates to queries using the new live directive. You can connect GraphBase to almost any user management software using JWTs or any OpenID Connect providers to automatically handle and authorize requests sent by users or groups of users. So let's check that out. Let's create a project with Clerk. We'll give it a name of GraphQL Galaxy. We'll allow passwords for our authentication type, and we'll create the project. Now that's created, we'll create a JWT template for GraphBase. And here we can configure many things, including the group-based authentication strategy. Let's install a few dependencies, including Apollo client, so we can make a request from our index page on our application, and we'll configure the Clerk provider using the Next.js hooks. Now we'll create our pages for signing in and signing up for accounts with Clerk. Thankfully, Clerk takes care of all of this by providing ready-to-go and ready-to-use components that we can embed inside of our application. So now we've added those, we can just configure a few more things, including our environment variables, so our front end knows how to communicate with Clerk and GraphBase. Let's run both our local CLI with GraphBase Dev and also our Next.js application. We'll create a new account with our email, and then we can update our index page to create a query that calls to our GraphBase backend. If we head to the index page, we should see that the query is running successfully because we are signed in, and we are sending a valid authorization header. This token is generated from Clerk, passed to GraphBase and validated. But if we update our schema now to only allow the delete operation, if we go back to our application and try to run the query to fetch all of our posts, we now should see that there is an error. If we inspect this error and have a look into why, we should see that the operation for the list type is no longer valid. Hopefully this very quick video has given you an idea on what backend to use for your next project. Check out graphbase.com where you can join the private beta for free today. Thank you.
Welcome everybody, thank you so much for joining me for this talk. I am very excited to be giving this in a lightning talk format. I've given the same talk before in a full-length format, and I've condensed it down into just the necessary pieces, so looking forward to see how this will go. If you have any questions about the talk after I've given it, feel free to shoot me a message on Twitter, and I'll be happy to answer any questions you might have. But before we get into the meat and bones of this talk, let's talk about the bigger picture concept that the world itself runs on data. Whether it's your cell phone, whether you're using Facebook, or maybe your refrigerator, or whatever you have that's connected to the internet, everything runs on data. And as developers, it's actually our job to manage this. So it's a heavy load to put on our shoulders, but that's what we signed up for when we became developers, is to actually take this data, do something with it, and spit it out in a format that other pieces of software can use. So the TLDR of all of this is that in order to manage a set of data, you have to have some sort of knowledge about its structure and its purpose. You have to know why you're dealing with your data and why you're doing what you're doing in your application's code to your data. So to revise this original statement, not only is it our job to manage this data that the world runs on, but it's also our job to, at least to some degree, understand it. And this is hard because, in general, data is hard to model. As technical people, we have a lot going on. We're doing a lot of technical things. We're developing applications. We have a lot of this knowledge to keep in our heads. There's not a whole lot of room to understand the whole data domain of whatever industry you're working in at the time. So a couple other reasons, though, why your data is hard to model. As your data flows through different areas of your application, you have to know how to interact with this data, so it needs to be modeled in a way that works with different pieces of your application. Your data model may change as your application evolves. So as new requirements come up in your industry, you may have to evolve your model a bit. And doing that in a way that's safe for your application can be difficult at times. Another one, and this is a big one, is that your data may not have been modeled by you. And I would also revise this to say your data probably wasn't modeled by you. You're probably consuming data from someone else and using it within your own application. So for all of these reasons, we as developers came up with this idea of schemas, which is a way to clearly and concisely represent your data model. But there's still a problem, even with schemas. Schemas are now everywhere. So we've solved this problem of being able to model out our data in a way that makes sense. But now that we found a good solution, we're using it everywhere. And the original intent for the schema is now lost. So what the schema is supposed to be is a source of truth for what your data looks like. But as you start adding different schemas everywhere, it begs the question, now what is the source of truth? So this causes the problem that you now have multiple perceived sources of truth. And each schema may describe your data a little bit differently, which is what probably causes the question, what is the source of truth? And also, each schema has a different role, and if the schemas look similar, it's kind of hard to determine what the role is of each individual schema. So to put this shortly, each individual schema in your infrastructure defines your data in the context of its own domain. So whether it's your database, your API, or something else, the schema is describing the data for that individual piece of your application. So we're going to look at a stack that has a database, GraphQL API, and Prisma thrown in there as well, so that we can look at the individual schemas and how they relate. So to start off, we'll look at the database schema. What you see on the right is the code that you would need to write to create a basic database schema. This is written in DDL, or a data description language, and it's typically a database-specific language here. So this is a little bit complicated. These languages tend to be a little bit harder to learn than something like JavaScript, or something a little bit easier to look at on the eyes. And for this reason, we at Prisma created our own language here called the Prisma Schema language. And this allows you to model out your database schema within a Prisma schema file. The only difference is that it's written in this language that's a little bit more like GraphQL. That's a little bit easier to read. This is important here because now as new developers come into your application, or maybe someone who's non-technical will come in, they can actually look at this model and sort of see what's going on. This is also important because it's in a simple enough model that we can actually use this within Prisma to generate a type-safe Prisma client that interacts with your database in a way that's safe and ensures that the data you're accessing is actually available. And then finally, we have the GraphQL schema here. So this looks similar to the Prisma schema. However, there is a big difference. This is where a lot of people end up getting confused with schemas. The GraphQL schema tends to look very similar to your database schema because it's exposing data from your database. But the problem here is that it should probably not look exactly like your database schema. This isn't defining your data here. This is defining what your API exposes. So, for example, to elaborate on this, you may be exposing data from your GraphQL API that's not even in your database. Or you may be not exposing certain fields from your database for security reasons. And because of these things, your GraphQL schema is a completely separate thing from your database schema. It may feel a little bit like code duplication as you're actually writing them, but if you understand this difference between the two different schemas here, it starts to make a little bit more sense. So just to recap, we've got our database schema, which is the schema running on your database server that defines your data shape. You have the Prisma schema, which will live in your API and your API's code. And this is actually what is used to generate the migrations to update your database schema. And it's also what's used to sort of create that mapping and to fill in the gap between the database and the API so that you can have nice type-safe interactions between the two. And then finally, you have the GraphQL schema, which is what the client uses to safely query your database via your API. But there is another gap there. So right here on this slide, I've got the gaps. And if we fill those in, what we get is we get Prisma in between the database and the API, as I'd mentioned. And you also get something like GraphQL Code Generator, or maybe another tool out there that does something similar. And what this does is it generates types for your front-end client based off of your GraphQL schema. So when you have all these pieces in place, all these schemas used properly, with these nice tools in between them, you get a nice end-to-end type-safe sort of situation and environment where your types, even from your client, are based off of your database types. So thank you so much for joining me today to talk about the differences between all of the different schemas that you might work with in your application. I hope it cleared some of those little things up about the different schemas that often confuse people. If you still have any questions, though, feel free to shoot me a message on Twitter about them. I'd be happy to answer. So thank you again, and I hope you have a good rest of your conference.
Hello and welcome to my lightning talk about GraphQL subscriptions with Kafka and Debezium. My name is Niels and I'm a freelance software developer from Hamburg in Germany. Let's have a look at this image here. We have 3 clients and we have a service that provides a GraphQL API. Client number 2 and client number 3 send subscriptions to the service to get informed about new customers. When client number 1 sends a mutation to add a new customer, our service and our GraphQL API can send events to client number 2 and 3, informing them about new customers. In real life, the setup might be a little bit more complex because we might have more than one instance of the same service, like in this case. In this case, client number 2 sends the subscription request to service instance number 1, while client number 3 sends its request to service instance number 2. Now, when client number 1 executes the mutation in service instance number 1, service instance number 1 can inform client number 2 about the new customer, but unfortunately, client number 3 does not receive an event because service instance number 2 does not know anything about the new added customer, about the executed mutation. To solve this problem, service instance number 1 must inform service instance 2 about things that happens, like the mutation. We can solve this problem by adding a message broker like Apache Kafka to our deployment. In this case, client 1 still sends a mutation to service instance number 1, but service instance 1, instead of sending the subscription directly to client 2, sends a message to the message broker. The message contains the information about the new customer, and both service instance 1 and 2 are listening to this message from the message broker. When they receive the message, they can send out the subscription data to both their connected clients 2 and 3. Both clients are happy now. In real life, things are a little bit more complex because we are writing data to a database. In this case, service instance 1 and 2 should write to the same database. And when the service instance 1 wrote something to the database, still the message will be sent to Apache Kafka, and both clients 2 and 3 get informed about the new customer. But in real life, things can go wrong. For example, after committing the new customer, service instance number 1 is not able to send a message to Kafka for whatever reason. In that case, none of the clients will receive an event. Also, what can happen is that we have another application that writes directly to the database so that service instance number 1 does not know about these changes and thus cannot send a message to the message broker, and again client 2 and 3 are not informed about the change to our data. To solve this kind of problems, we can add a change data capture tool like Debezium to our tool stack. A change data capture tool reads everything that happens in your database, like inserts, updates, and deletes, and writes events for these actions to a message broker. In case of Debezium, Debezium publishes change events to Apache Kafka. A Debezium change event might look like this. It has a source attribute where the table, for example, is set. It has an operation like update, delete, or insert that describes what has happened in the database, and it has the before and after data. In this case, the before and after data of an update operation. Our architecture with Debezium would look like this. Client 1 still sends the mutation directly to service instance 1. Service instance number 1 writes the new customer to the database, or another application writes something to the database, and in both cases, Debezium picks up the changes directly from your database and sends a CDC event message to the connected message broker. Both service instance number 1 and number 2 receive this CDC, change data capture events, can interpret these events and send subscription data via their GraphQL API to client number 2 and client number 3, and both clients are happy now. Thanks to the delivery guarantees that Debezium and Apache Kafka gives us, we can be sure that any change in the database, any update, insert, delete, will be published to Kafka and will be received by our service instance, so that we can be sure that we can send a subscription for any change in the database for whatever reason the database has been changed. If you want to try out this yourself, I built a small sample application built with GraphQL Java and Spring for GraphQL. You find the source code in the GitHub repository in the URL below. By the way, this technology stack we can not only use for subscriptions, but I think also for queries. We could build a dedicated read model database for our GraphQL API. Imagine we have a list of microservices, each connected to their own database. Using Debezium and Apache Kafka, we can pick all changes to all databases and build a dedicated, optimized database only for our GraphQL API. The GraphQL API then can read the data from this specific database and does not need to query all the microservices to get the data that is requested in a GraphQL query. So far, thanks a lot for today. See you and have fun building GraphQL APIs.
All right, those are some terrific talks. Thank you again so much to Scott, Jamie, Sabine, and Nils for those great presentations. So I'd like to bring Uri and Alex back on the stage with me. Uri?
Hi, everyone, again. So with all those amazing talks, we're now towards the end of the GraphQL Galaxy for today. At the start of the event, though, we told you about the raffle, and it was so nice to see all those engagements on Twitter. So thank you for tweeting and participating and doing all of those. So now it's raffle time. Let's take a look at the tweets together.
All right, so we selected 2 finalists from the photo tweets today. First, thanks to Nuanko for tweeting your setup. Great to see that you're watching and enjoying the GraphQL Galaxy conference today. We also have Jem and Bronte, cute kitty cat, joining. I actually had my dog with me today as well for part of the conference. So thank you so much for sharing your setup. So we'll go ahead and start with a raffle between these 2 photo finalists. Right, so let's get that pulled up here. Perfect. All right, so we'll go ahead and spin and see who wins. And again, this is for a Get Nation multi-pass and a t-shirt. All right, let's see. Oh, looks Looks like it's going to be Jem and Bronte. Congratulations, Jem and Bronte. I don't know if we have cat-sized t-shirts, but we'll see what we can do. The organizers will reach out to you to get you set up with your prize. Thank you again for participating.
Cool,
Alex?
Congratulations. And also we have a second raffle for those who were active on Twitter. So we found 4 people: GigaChat, Soham, Raul, and Jason. Let's find out who also win a multi-pass and a Git Nation t-shirt. Congratulations to GigaChat. The Git Nation team will reach out to you to get you that multi-pass and t-shirt.
Congratulations to all the winners. Well, this was a very long and busy day, full of a lot of learnings and a lot of amazing talks. We would like to, first of all, to thank all of our speakers for spending their time, sharing their experience and knowledge with us. It was great. And also, we'd like to thank all of you, our audience, for being with us and for watching and participating in the chats, in the discussions, and in the Q&A rooms.
And once again, thank you to our sponsors for all your great support of GraphQL Galaxy, Solo.io, Neo4j, StackHawk, Honeypot, and Focus Reactive. Again, your support makes all of this possible, so thank you. And of course, Git Nation team for organizing. What a great event. Thank you so much for putting this on today.
And if you want to attend more conferences for the Git Nation team, get the Git Nation Multipass. You can find out more on Git Nation portal at portal.gitnation.org. And you can subscribe to get more talks from previous events. All of today's recordings will be uploaded to portal.gitnation.org. You can check it out there. Full ticket holders will get instant access to them, and free attendees will have access to them later, around a month or so from now. And again, like I said at the beginning, your feedback is very valuable for the Git Nation team. So send feedback about everything. And we hope that with your feedback, we can make all the next events even better. And as a reminder, there will be 4 discussions rooms tomorrow. Don't miss it too, and you can join the special chat, talk with a lot of other GraphQL developers. Also speakers, some speakers will be there. You'll get the schedule, the exact schedule on the email, on the list via email.
All right, well, yes, now it is time. If you think that's it, you're wrong. You can't leave without the remote after party, right? So everyone is welcome to participate in the after party program. We're super excited to have y'all here. We will be playing some games. We have draw battle, code names. There's also chat. If you've never been in the spatial chat, it's really fun. There's things like you can post videos and you can wear funny hats, and it's really cool way to interact with people, especially in a remote environment. So definitely check that out. You will find the link on the watching page in the portal. So
we'll see you at the after party. Thanks everyone for watching.
Bye everyone.
Thanks everyone. Cheers.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com. Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying town, from London to Taiwan. I've been all around the globe trying to protect your soul. We are
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.